Welcome to Master React with TypeScript, the most complete, modern, and practical course designed to teach you how to build modern, robust, type-safe web applications. This course covers everything from the basics to advanced topics such as integrating authentication with providers like Google, managing payments with Stripe, deploying your application, and make it accessible to millions of users, and more. I spent months carefully designing the structure of this course to ensure it's easy to follow for everyone, from absolute beginners with no coding experience to experienced engineers transitioning to web development. Whether you are just starting out or looking to dive into advanced concepts, this course is for you. Unlike any other courses, this one isn't about building a simple dummy app. Instead, it's focused on helping you develop strong foundations in React, TypeScript, state management, performance optimizations, and modern design patterns. Only good stuff that you're actually gonna need in the real world. You'll also gain experience with cutting-edge frameworks like Next.js and learn how to write unit tests. But that's not all. To truly stand out as an engineer, you need to have an eye for design and a strong understanding of clean, user-friendly UIs. This course guides you through design fundamentals using tools like Figma to build beautiful interfaces, adhering to design systems, creating reusable components, and exploring different styling approaches such as inline styles, CSS modules, Tailwind CSS, and more. After mastering these foundational lessons, the final section brings everything together. We'll build a real-world application, applying everything we've learned throughout the course. Together, we'll go step by step creating an application, integrate Firebase as the backend, and Google authentication, save users to a database, fetch data, work with dynamic routes, implement Stripe payments, handle webhooks, and post-payment business logic, display products, and deploy application. I think this is a great final project that actually gives you the power to build an application for yourself and start selling products and making money as a software engineer, and also gives you the experience of creating a SaaS application. This video is just a small glimpse of what's included in the Master React with TypeScript course at codewithbeto.dev. The full course covers so much more. My name is Beto, and I'm a passionate software engineer with years of experience building robust applications using React and React Native. Currently, I work as a software engineer at Expo, where I help hundreds of thousands of developers to be successful with Expo tools. Previously, I worked as a software engineer at Walmart, where I had the opportunity to see firsthand how large companies shape thousands of applications in a scalable and efficient way. Over the years, I've worked in hundreds of code bases and gained invaluable experience in building real-world applications that follow industry standards and best practices. Through this journey, I've learned how to approach software development in a way that's both scalable and practical to real-world use cases. I'm also the creator of Code with Beto, an online learning platform with more than 10,000 registered software engineers, as well as the creator of this YouTube channel, where I share my knowledge and tips with anyone who shares my passion for software development. This course is the culmination of everything I've learned throughout my career. It's a course I wish I had when I was first learning React. Creating it's my way of giving back to the community that has supported me throughout my journey. I genuinely hope you'll join me in this learning experience. Whether or not you decide to enroll in the course at Code with Beto, I want to thank you for being here and hope this small preview of the course benefits you and inspires you to keep improving and learning. It's a privilege to be part of your learning journey, and if you have any questions, please don't hesitate to reach out to me. You can find links to my social networks in the description, and I'm always happy to meet passionate developers. With that, my dear friends, here's the course. Let's get started. Hello everyone, and welcome back to Code with Beto. I'm thrilled to have you here for the introductory lesson to React. First of all, let me congratulate you, because if you are watching this lesson, it means that you have decided to take this React with TypeScript course. You are ready to put the effort and time required to become a master in React, especially with TypeScript. But before we dive into the topic, I just want to mention that I recommend taking this course in order, from the introduction all the way to building the final project. This is particularly important if you are a beginner with React and TypeScript. As you may have seen on the landing page, you don't need prior knowledge of React or TypeScript to benefit from this course, but a solid foundation in CSS, JavaScript, and HTML will be helpful. With that being said, let's start with the first lesson of this course. First of all, let's start with the right foot. What is React? Well, by the definition that we can find on their official documentation and website, they said that it's a library for web and native user interfaces. So React is a library, and it's going to allow us to create web and native applications. And maybe you have taken the React Native course here in Code with Beto, but if you haven't, I would highly recommend that you take that course after you take this React course. So you learn as well how to create beautiful native applications using React as well. Alrighty, so we know that React is a library, but what is a library? In the context of programming, a library is a collection of pre-written code that developers can use and reuse to avoid reinventing the wheel. Libraries provide tools and functions for common tasks, helping developers building applications more effectively and with less code. For instance, React is a JavaScript library used to build user interfaces. It provides a set of tools and functions that allow developers build complex UIs from isolated pieces of code called components, and we're going to learn more about components in the future lessons. But by using React, developers can avoid writing complex UI code from scratch and instead focusing on building a unique feature for their applications. And I have just illustrated this by putting these Lego blocks. And I want you guys to think of these Lego blocks as components. This is like the magic of React. We can modularize the code so we can reutilize these code blocks at the end of the day, or also known components, right? So for example, let's say that we have this very simple functionality here, and we abstract this so that when we need to have this structure here, we can simply grab the same component that we had before and use it 3 times. All right, this is basically how React works in components. Let's continue. All right, so at this point, we have a pretty good idea of what is React, but now let's see who uses React in the real world to build complex applications that can scale to billions of people. And here we have famous companies that use React. And if you didn't know, Meta was the creator of React, which means they use React for building almost everything: Instagram, Facebook, and all their internal products, I would say. Also Tesla, GitHub, we also have Slack here, Twitter, now named X after Elon Musk. Also we have Adobe, Oracle, the New York Times, Airbnb, Netflix, Uber, Microsoft, Walmart, Dropbox, and the list goes on and on. I just put these applications that I think are really famous, and they are the living proof that building applications with React can scale to billions of people. So if you would like to get a job working at Tesla or Walmart as a software engineer, Netflix, or even Meta, you would need to learn React at some point, and it will be really beneficial if you already know React. Now, another great point that we can abstract by seeing who is using this framework or library in the real world is that React is going to stay for a long time, I would say, because these robust companies are going to make sure that React is not going to die anytime soon, and React is going to keep improving. To illustrate that, I have here a screenshot that I just took from the NPM trends. And as you can see here, for the past 5 years, React has been on fire, just increasing its popularity between developers and companies. Because if small companies or startups are seeing that the big tech companies are using React, it's obvious that they need to focus on this framework that has proven to be scalable and has proven to be easy to learn and allows us to write scalable code. So here you have it, guys. As you can see, the popularity of React is been increasing for the past 5 years, and I can bet that it's going to continue like that at least for the next 10 years. So learning React is going to be one of the greatest investments that you can do in your career as a software engineer, especially nowadays. Now, to finish this introductory lesson, guys, I just want to mention some advantages of using React apart from being backed for big tech companies like Meta. React is also easy to learn, especially if you already know HTML, CSS, and JavaScript. And if you are not really familiar with those topics, I would encourage you to go to their official documentation and learn at least the basics of HTML, CSS, and JavaScript before you dive into the more complex stuff in this course. So it's easy to learn. Oops, here you have it. And it's open source, which means that we have developers from all around the world contributing to React, which is going to keep improving this framework. And also we have libraries from other developers that we can use with React. And that allows us to keep developing quickly and stop reinventing the wheel. Now we know that React allows us to build applications that are scalable, and we have the proof by just seeing the big tech companies' products. Like I mentioned before, apart from open source, we have this huge community. React is one of the most, if not the most famous framework in the community of developers, especially front-end developers. So React, I would say that nowadays it's a must know, and it's really important. And it's really nice as well that we have a great community and a large community, because if you get stuck somewhere, you are going to find help very quickly by someone in the community. Also, another huge advantage of React is that React allows us to write applications that are cross-platform. And if you know React, basically you already know React Native. Of course, there are some differences, but if you want as well, we have a React Native course here at Code with Beto, and I would highly encourage you to take that course after this one, so you can unlock the full power of knowing React, which is that you are going to be able to write amazing web applications and fully native applications for mobile devices. Now, to finish with this introductory lesson, guys, I just want to mention that you can use the react.dev website to reinforce your learning. And just to come here and read a little bit about React before you dive into this course, it will be very beneficial for you. If you don't understand anything, don't worry. We're going to be explaining every single topic on this course. So this is how the landing page of the react.dev website looks. And here you will find the documentation for each API and method or functions that come with React and how you can use it. It's really helpful, and I would encourage you to go to reinforce your learning after you see the topic on this course. Maybe you can read a little bit on the documentation. Now just let's scroll here a little bit. As you can see, React is going to allow us to create user interfaces. And here we have just small examples of how we can use React and how the components worked. As you can see, React is going to be like the combination between HTML, CSS, and JavaScript, all in the same file. And we are going to learn more about that in the future lessons. Now, I just want to show this a little bit and abstract the most important things, that React allows us to basically create components or pieces of code that we can reutilize. In this example, we have three components that are being reutilized 3 times, right? Now, this is an important thing. Go full stack with a framework. And I don't want to confuse you guys. I don't want to confuse you right now, but we're going to learn more about frameworks in the next lesson. I just want to mention that React can work with another frameworks and allows us to unlock more capabilities and ship better applications and websites. In this course, we are going to be focusing on Next.js, as you can see here, but we have other alternatives like Remix. Finally, like we mentioned before, if you know React, you already know how to create native applications using React Native. And we also have a course here, so don't miss it out. Go and check it out. Now, with that being said, welcome to the React community. I'm super excited to go in this journey with you, and I hope that this course proves to be very valuable to you. That's it for this lesson. I hope you enjoy it, and I'll see you in the next one. Bye. Hello everyone, and welcome back to Code with Beto. In this lesson, we are going to learn about the difference between a library versus a framework. In the previous lesson, we talked a little bit about what is a library, but today I'm going to give you a better understanding so that you can differentiate easily a library versus a framework. So let's get started. As a reminder, here we have this kind of slides that I created for the previous lesson. And just as a reminder, we said that a library is a pre-written code that allows us to avoid reinventing the wheel. And I have here these Legos that we can assemble and create something more complicated. But this is what is a library. It's just code that we can use. So a library is more flexible. We can use it as we want. We can use it in a bad way or in a good way. Now, what is a framework? A framework is a structured set of tools, guidelines, and best practices that provides a foundation for developing software. What do I mean by this? Let's imagine, or let's keep in mind, that a library is just a very low-level tool that we can use to create something, right? For example, a website, we can use React. React, it's a library that comes with functions, hooks, and some stuff that we can use to create websites. React is very flexible, and we could naively use React and start creating components, start adding stuff, and integrating workarounds for things that we cannot do with React, like routing or fetching data. So a framework utilizes these foundations of React, for example, and gives you tools, pre-written tools, or more robust tools that we can use to build something a little more complicated in a way that is more scalable. So a framework is going to allow us to build faster in a manner that is going to be scalable and easy. As you can see here, I have these little icons, guys. It's an axe, it's a hammer, and this thing, okay? This is what a framework gives us. It gives us tools that we can use to build something complicated like this building. Now, of course, we need to know what kind of framework we need for the work. In this case, we use the axe, for example, to cut wood. We use this thing to make a hole on the ground. And this is how frameworks for developing works as well. We need to choose the one that we need for the job. Okay, now I want to show you this image, guys, that I have down here. Basically, this is the image that I think when I think of a framework. This is a framework in construction, and basically this is what a framework gives us. And think of it as a boilerplate code that we can grab and follow to keep building on top of that. So let's say that we already have this house that we are building, and this is what the framework gives us. Now, as you can see, we have some windows, we have like the structure of the house, but now we can easily start creating, let's say, a wall that is going to be between the house, and it's going to divide this house, right? We can grab this framework and put another one on top of this one. So this is going to be a 2-level house now. And this is what a framework gives us. It gives us a structure that we can follow and allows us to keep building in an easy manner in a way that is going to be scalable. I hope that makes sense. Now let's stop talking a little bit about construction and let's actually talk about React and what frameworks use React. Here I have some of the most famous frameworks that use React, and you may have heard of them: Remix, Gatsby, Next.js, and React Native, for example. All these are frameworks or set of tools that we can use to build specific applications. For example, React Native, it's mostly used for mobile applications for iOS and Android. And if you haven't, you should check out the React Native course that we have here at Code with Beto. But I want to mention, guys, that when we are using a framework for developing specifically for web, we should be very familiar, or at least know what advantages provides a framework and why we should use a framework in the first place. Now, in the first sections of this course, we are not going to be using any framework, just raw React without any framework, because we need a really good understanding of React before we jumped into a framework like Next.js or Remix or Gatsby. Now, I don't want to waste too much time talking about Remix and Gatsby or Next.js and React Native, because it's just, I just wanted to show you this as an example and tell you that we have frameworks that are using React as the engine to build on top of that. Okay, guys, now that we know some of the frameworks that are out there available for us to use, we need to choose one. And of course, like I mentioned, we're not going to be diving right into a framework because we need to really understand the basics of React and also TypeScript before we jump into one of these frameworks. These frameworks allows us to move faster, but they also require to have a really good understanding at least of React and TypeScript, or at least JavaScript. Now we're going to be using a framework, right, to build the final project and some of the lessons of this course. And the framework that we are going to be using, spoiler alert, it's going to be Next.js. And Next.js, it's the one that we're going to be using for a couple of reasons. The first one is that it's one of the most famous frameworks and widely used on the community, open source. So it's open source, everyone can see the code and contribute. And also it's very well maintained by Vercel, which is the company that created Next.js. And also they provide us with a lot of tooling that we can use to keep scaling this application. So a part of the framework, they provide us with tools, for example, to deploy the application, to have analytics, to connect the database. And of course, if you want to explore more about other alternatives, you are welcome to do that. But I would encourage you to learn Next.js because it's the most famous in the community. It's very large and you are going to have a lot of help around and also a lot of opportunities. If you are trying to get a job, React and Next.js should be your primary focus. Of course, if you want to work for a specific company that you know that use, for example, Remix, maybe you should learn Remix. But that being said, guys, I want to talk a little bit about other advantages of using Next.js. Next.js is a framework that it's well known for being a full stack framework. When we are using Next.js, we also have the ability to have some endpoints and handle requests into the same project. So we're going to have the front end and the back end in the same folder. And we're going to learn how to use these API routes in more advanced lessons. But this is a huge advantage because a lot of times we need a backend. And if you need just one API, Next.js is going to allow you to do that easily. This backend can be easily deployed to Vercel as well, so that you can use this API in production. Another huge advantage of Next.js is that they allow us to use the latest React features. We are going to learn about this as well with the new features like server components and the new experimental hooks. These kind of new features of React are going to be available to us using Next.js. Don't worry if you don't know anything about server components, we're going to learn that in this course as well. Another advantage of Next.js is that they support server-side rendering. Basically, this helps to improve the initial page load and improves the CEO as well. Also, they have support for static site generation, or SSG, and basically allows us to build static pages. And if you are trying to build, for example, a blog, you can use Next.js, and this is going to improve the performance of your application because basically this is going to pre-build your application and then send it to the client. So we don't need to wait to compile this code. It's going to be just now available since the first load. So this is going to improve the first load. They also have support for incremental static regeneration, and this allows for updating static content incrementally without rebuilding the entire site. So let's say that you have a blog, but you have some parts of the application that need to be updated. You can use ISR to incrementally re-render parts of your application. Also, this is going to improve the performance and the load time. Another huge advantage of Next.js is that they provide us with a file-based routing. So when we are using React, we don't have any built-in solution to manage the navigation in our application. And Next.js provides this file-based routing system that works pretty well, and it's very scalable. And we're going to learn more in the future lessons. And finally, one of the huge advantages of using Next.js is that they have first-class support for TypeScript. We want to be focusing on TypeScript, so that's why we need a framework that supports TypeScript very well right out of the box. So these are some advantages, and this is why we're going to be using Next.js throughout this course to build a final project, to build a real world application that we're going to be building. And I hope that you like this lesson, guys. I hope that you learn something new, that you have a better understanding of the difference between a library and a framework. I encourage you to go and investigate if you are curious about other frameworks, if you are curious about the difference between library and framework, and if you want to learn a little more, go out and Google whatever you need. And otherwise, I hope you like this lesson. I hope you learned something new, and I'll see you in the next one. Thanks for watching. Bye. Hello everyone, and welcome back to Code with Beto. In this lesson, I'm going to give you a little introduction about TypeScript. This is perfect for those who never used TypeScript before, and we're going to learn just a little bit about TypeScript. This is like the presentation, like the introduction for the first time. We are not going to be learning TypeScript in detail in this lesson. We are going to be doing that in future lessons, but just as a little example and presentation of what can we do with TypeScript and what is TypeScript. Let's get started. First of all, we need to define what is TypeScript. TypeScript is a strongly typed programming language that builds on JavaScript. So what does this mean? TypeScript allows us to basically use JavaScript on the background, and on top of the features that we can use with JavaScript, we are adding the missing piece when we are using JavaScript, which is the types. TypeScript was invented and it's actually maintained by Microsoft, which is really good because Microsoft, it's a huge tech company that is going to be maintaining TypeScript in a good way, and it's going to be improving over time. Also, you may have heard that TypeScript is a new industry standard because it allows us to add types, like you can see here. And that's why a lot of companies are using TypeScript. So I'm sure that learning TypeScript is going to be a really good investment in your career and in general in your knowledge. Okay, so now that we know what is TypeScript, we know that is like types for JavaScript, but what is JavaScript, right? So JavaScript is a programming language that enables interactive and dynamic content on web pages, running primarily in web browsers, but JavaScript nowadays is used widely in a lot of applications. So it's used on web applications. Also, it's used on mobile applications like iOS and Android. And it's also used on the server using Node.js. You may have heard of Express.js, Nest.js, and a lot of frameworks that use JavaScript as backend. So if you have a framework or you are doing something in JavaScript, it means that you can also do it with TypeScript. Now, you should know what is JavaScript at this point, but if you don't know, I would encourage you to go and learn at least the basics of JavaScript, and then you come back to this course because we're going to be doing some things with TypeScript, and you should already know a little bit of JavaScript. But let's continue. Let's see actually an example of how JavaScript looks. This is how JavaScript looks. You may be familiar already with JavaScript, but we have a function here that is just calculating the area of a circle. So when you are trying to calculate the area of a circle, you need to calculate p multiplied by radius multiplied by radius. So here we are receiving this radius as parameter, and then we are just saving the result of this function inside this variable const area and just calling this calculate area with 5. Now, when we are using JavaScript, this is like the error of JavaScript, or the missing part of JavaScript, because JavaScript is a dynamic typed language, which means that if you don't provide like the type, well, you can provide, but you can like initialize the value. For example, in this case, we could have said radius equal to 0, which is going to infer, JavaScript is going to infer that this is going to be a number. But yeah, in this case, we're going to be passing this 5, but if you pay attention, this 5 is a string. Now, we are not going to be able to catch any errors. Let's say that we are just getting this input from the keyboard, and that input is going to be taken as a string. So that when we call this operation with this function, the result is not going to be a number, as you can see here, NaN, which is not a number. And yeah, so this is an error. And just by using JavaScript, we wouldn't be able to catch this error early on. Now, let's say that we don't realize that we are getting strings here and we ship this application to production. That is going to be a lot of mess because users are not going to be able to just create this simple function or call this simple function and get the result. And this is like the huge downside of using JavaScript. And you may have heard for a lot of software engineers telling that JavaScript is just a toy language because of this. But don't worry, because thanks to TypeScript, we can strongly type now these kind of functions using JavaScript, and we can catch errors early on development. So let's see now an example using TypeScript. Okay guys, so here we have the exact same example, but in this case we are using TypeScript. TypeScript, the way it works is just by telling JavaScript what type of variables we should expect. In this case, we have this radius, and we are specifically telling to this function that this radius variable should be a number, as you can see here. And also we can specify the return value for this function. And that return value to this function is going to be a number as well. This is how you can type variables. You just have to put this colon and then the name of the type. We also have other types like strings, booleans, arrays, tuples, enums, any, void, and don't worry, we're going to learn every single one of them in the following lessons. But I just wanted to show you how a very basic example of TypeScript looks like. Now let's go ahead and call this function down here. We are passing the same string, 5. It's a number, right? But it's a string, so the computer doesn't know the difference between a string and just the 5, which is a number. So we would get an error in this case. And if we are using VS Code, for example, to write this code, we would get like a warning, and this would be like red. And yeah, the error in this case is that the argument of type string is not assignable to a parameter of type number, as you can see here. All right. This is because we strictly specify that this was going to be a number. By doing this, guys, we are allowed to catch errors very, very early on development, which is going to allows us as well to ship better applications with less bugs. This is huge for huge applications when the code starts to get complicated and a lot of pages are coming in, a lot of features. Using TypeScript is going to be a lifesaver. And that's why this is the main reason why we should use TypeScript in every single project that you create, especially if it's going to be a large project. If you are testing just something small, maybe you should use JavaScript, but for a real project, you always should use TypeScript. That being said, let's talk a little bit about some other advantages of using TypeScript. So guys, like we saw before, we have static typing, we have a better code readability, which means that other engineers can come and see your code. And because it is strongly typed using TypeScript, it's going to be easier to understand and read the code. Like I mentioned before, we have IDE support, which means that if you have an error using VS Code, for example, as your IDE, you are going to get the highlight telling you what's wrong before you ship this application to the user, okay? Scalability, TypeScript, it's better suited for large code bases, like I mentioned before, and it's going to make it easy to maintain and refactor. Then we also have interoperability. This advantage is that it's compatible with existing JavaScript code, libraries, and frameworks. So if you are using TypeScript, we can also use libraries that use JavaScript without any issues, okay? Then we also have advanced features, and this includes features like interfaces, generics, and enums, and allowing for more robust and flexible coding. And we're going to learn more about enums, generics, and interfaces in the following lessons. But this is huge. Basically, those interfaces allows us to create or custom types for specific data structures. And that's really nice. That's really cool. And this is a huge advantage when we are using TypeScript on React. And we are going to see how that is going to work in the following lessons. And finally, we have a community and ecosystem, strong community support, and wide range of tools and extensions for TypeScript. So don't worry about getting stuck because there's a lot of help out there. And yeah, so I just wanted to mention these guys for this lesson. I hope that this inspires you to adopt TypeScript and learn TypeScript. I'm sure it's going to help you to level up as a software engineer. And I hope you like this lesson. I hope you learned something new. And I'll see you in the next one. Thanks for watching. Bye. Hello everyone and welcome back to Code with Beto. In this lesson, we're going to learn how to set up Node.js so that we can start building web applications using React. Also, we're going to learn a little bit about what is Node.js and what can we do with Node.js. So let's get started. Okay guys, so the first thing that we need to do is actually go to the nodejs.org website and download Node.js to your computer if you haven't already. I would recommend that you use the recommended version, which is 18 at the time that I'm recording this video. The way you install Node.js is just clicking on this button and then install the package that is going to be downloaded on your computer. Now, once you have Node.js installed on your machine, you can verify that it's been installed by opening your terminal and then run the command node passing the flag v. And if I hit enter, you can see that I have the version 16.18.0. All right, so now I have verified that I have Node.js on my computer. But if you pay attention, guys, I have the version 16 and the recommended one is 18. It's okay in my case to have the version 16, but that brings me to the next topic. We often are going to be switching between versions of Node.js depending of what framework we are using or depending what we are trying to build. For example, if we go to the next website and check the documentation super quickly, and let me make this a little bit bigger, on the part on the installation, you can see that when we are using Next.js, which is a framework that utilizes React, right? We saw this on previous lessons. The requirements are that we need Node.js 16.8 or later. So on my computer, I have 16.18, which is a little bit below the recommended one or the required one. When we are using, for example, other frameworks, or let's say that we're using a version that is old, that it's been out for a while, we're going to be needing to switch between versions that are in this case 16, or maybe we are using another framework that uses version 20. So we need a way to manage this on our computer in a more reliable way. Well, thankfully, we have NVM. NVM, it's basically a program that allows us to manage versions of Node in our computer, as you can see here. If you have never seen NVM, don't worry, I'm going to introduce to you a Node version manager, right? It's just a simple program that allows us to switch between versions of Node into our computer. If we go to the install and updating part, you can see that you can install this on your computer. If you are using Mac, you can use curl. Just copy paste this link or this command and you're going to be able to install NVM. Now, if you don't know if you already have NVM on your computer, you can open your terminal again. I'm going to bring mine here and simply run nvm-v. So here I have the version that I'm using, in this case nvm. It's 0.39. So this means that I already have NVM on my computer. Now, the way we can use NVM to switch between versions of Node in our computer, it's by just going here to the simple example that we have here on the intro part. Now, here we have another description of NVM. Basically allows us to quickly install and use different versions of Node via the command line, which is really handy. We can see the list of versions that we have installed in our computer. For example, if I run nvm list, hit enter, you are going to see that I have these versions. I have 14, 16, and 19. Okay. Now, if we want to, like for example, set a default, we can do so. In my case, the default is going to be 16. But if I want to change this for the latest one or the stable one, it's going to be the version 19.4. If I want to use this version, I can simply go down here and say nvm use stable. I think if I hit enter, you can see that now I'm using Node version 19. And if I clear my terminal so we can see a little better, and I run node-v, hit enter, you can see that now I'm using version 19. But I can switch easily if I just say nvm list and use whatever version I want. Now, if I want to install a new version, what we can do is just use or run the command install. As you can see here, let me make this a little bigger so you can see better. You can see npm install. For example, let's say that you want to use the 20, npm install 20, and then that's it. You're going to be using now the version 20. Now, I wanted to show you this, guys, because this is really important, especially if you are going to be using a lot of frameworks or you are running a repository or a program that is a little old. You're going to be maybe switching between version 14 and 19 if you're working on a more recent project. We have at this point installed Node in our computer. We have NVM, which allows us to change versions of Node in our computer. But we have Node.js installed, right? So that was super easy. We just need to click here, download, and that's it. But what is Node.js? Well, Node.js is an open source, cross-platform JavaScript runtime environment. We as developers need to run the code that we are writing, right? And we need an environment when we are developing these applications. Normally, the browser is the one that runs our code, especially when we are creating web applications. But when we are developing applications, we need, for example, especially if we're working on the backend side, we need a way to run the code that we are writing. So Node.js is basically what we use to run the JavaScript code that we are writing. All right. Now this might be a little confusing, but just as an example, let's quickly create a super simple file here. I'm going to bring my terminal, and what I want to do is just clear my terminal and go to my desktop. So I can say cd desktop. And now that I'm on my desktop, I want to create a new file. So I'm going to say Vim. Vim is going to just generate a new file based on the name that I'm going to provide. In this case, it's just going to be testing node.js. Okay, so this is going to be, let's say that I'm building something and I'm going to create a JavaScript file. So testing node.js and hit enter. Okay, now I'm inside this new file that I just created. And what I want to do here is just start writing JavaScript. So I'm going to say console.log. This is a test. Okay. Okay, so this is JavaScript. And maybe you should be familiar with this syntax. This is JavaScript, and I'm just putting on the console, this is a test. So let's save this by saying write and quit. Okay, if I hit enter, now I have created this testing node file, and inside this testing node file, we have that console log that I just wrote. Okay, now we have the code, we can see it here, we have the file, but how can we run this code? That's where Node comes in. In this case, we already have Node installed in our computer. So I can simply say Node and then put the file that I want to run. In this case, it's going to be testing node.js. And if I hit enter, Node is going to grab this file and basically run it. Because it's JavaScript, it's going to work. And if I hit enter, you are going to see that my code ran. Okay. And if I go back to my testing node file, and you can see that I have this console log. Let's say that we want to create a little more complicated, something more complicated. So let's create a for loop. Let I equal to 0, and then I less than, let's say 10. Oops, 10. I plus plus. Okay, so at this point we are doing something a little more complicated. We are using for loops, but this doesn't really matter. I'm going to put on the console, this is a test, and then we can pass maybe the index plus 1. Okay, so let's save this and run this again. So if I say node testing node, you can see that this test worked perfectly fine. So this is what Node.js does on the background, basically. We are going to be writing JavaScript code or TypeScript code or React code, and we need a way of compiling this code or running this code. And that's why we need Node.js. Node.js is the one that does that for us. Okay. Well, now that being said, now that we know what can we do with Node or what Node is going to be doing for us. Finally, guys, now before we end up with this lesson, I wanted to mention that Node.js is not only used on the front end, it's also very popular and very widely used on the backend development. And if I go here to the docs, for example, you can find examples and sorry, to the about section, I think. You can see that we have here examples that are being used on the server side. So, and that's really cool because we, just by knowing JavaScript, it means that if we want, we can create also server-side applications and then become full stack developers. And we're going to be using some server-side properties in the future when we are implementing the final project with Next.js. But for now, it's good to know that we can also create backend applications and also CLI applications using JavaScript. And Node.js allows us to do that. And finally, to end up this lesson, I just wanted to mention that Node.js uses V8. What is V8? Well, V8 is Google's open source high performance JavaScript and WebAssembly engine. So basically, this is like the engine that Node.js uses, or Node.js was built on top of. Okay, it was written in C++, created by Google, and it's used by Chrome and Node.js, among others. Okay, so when we are basically using Chrome, we are using this engine to run the code, JavaScript, and all that stuff that is happening under the table. V8 is doing that, and Node.js is using this engine as well. Now, I hope that this gives you a better understanding of what Node.js does, what's the role of Node.js on the development, and how can we use it. And if you want to learn more about V8, I encourage you to go to this official webpage. And yeah, guys, so this is all I wanted to show you for this lesson. I hope that this lesson gave you a better understanding of what is Node.js and how we can use it and where we use it for developing applications. That's it for this lesson. I hope you like it, and I'll see you in the next one. Hello, everyone, and welcome back to Code with Beto. In this lesson, create a new React app. We will explore how to set up a brand new React application using different methods. And by the end of this lesson, you will be able to bootstrap your own React projects and understand the tools involved. So let's dive in. Okay, guys, so here I have opened my browser. And as you can see, I am on the Next.js documentation. This is a Next.js framework, and this is one of the most popular ways to create a React application. I also have here Vite. Vite, it's another way to create and bootstrap development environments. And Vite is mostly used for different frameworks, not only React, but we also have Vue, for example. Then we also have the all good create React app. This was the most popular, I would say, way to run a React application, but now it's not very used too much now because we have another alternatives like Next.js, and also we have something like Code Sandbox. If you have never used Code Sandbox, it's super easy to use, and we're gonna see how that works in a moment. Now, I just wanted to show you guys that in the React dev documentation, you have this section that says start a new React project. And here they are telling us, here, this is something really important. We need to install Node.js. That's why we did on the previous lesson. And they are also showing us that we can create applications or React applications using frameworks like Next.js. Then in order to create a new Next.js project, we need to run this on the terminal, and that's it. We can also use other frameworks like Remix or Gatsby, as you can see here. And also, if you want to create React Native applications, we can also use Expo, for example. All right, so these are some ways to create React applications, but in this case, all these alternatives are using frameworks. And we don't really want to jump into a framework right away. We want to learn the basics of React, and we want to learn how React works, what about hooks, how React works with TypeScript before we jump into a framework, okay? So let's actually close Next.js because this is a framework. Vite allows us to create a a React project and also comes with some configuration, which is pretty nice. We also have create React app. And finally, I wanted to show you Code Sandbox. So when we are using Code Sandbox, we can simply press on new sandbox and you can simply select the type of application that you want to create. Now, because this course is focusing on TypeScript, let's choose React with TypeScript. And after 1 second, you will have your first React application, as you can see here. Now, this React application is using TypeScript, as you can see on the left side here. We have this app.tsx file, index, and we have a lot of stuff that you may not familiar with. But the cool thing about this is that we didn't have to do anything, just 2 clicks, and we are able to see this React application on the right side. Now, if I start editing this text, for example, delete that and change this to be my first React app and command save, you're going to see that this is going to save this file and update the browser that we have on the right side, right? This is how we can create this application. And I would encourage you guys to use Code Sandbox to play around with React, to try some things, and also just for basic stuff. But also, I wanted to mention that if you are using Code Sandbox, it's really nice, especially if you don't want to set up your local development environment, if you don't want to use Node.js in your computer. This is all working on the browser, so you don't need to install anything. Or for example, if you are using another computer one day and you want to do something with React, you can just go to codesandbox.io and you're gonna be good to go. Also, you can, deploy this project and do a lot of things. But yeah, you're going to be limited to this user interface, to these buttons. So most of the time when you are creating a serious project, you're gonna be on your local machine, using, for example, your favorite IDE, which is VS Code in my case. And yeah, so you're gonna be able to have more control over your environment. But this is a really nice way to create a new React app. So the one that we're going to be using to create our very React app is going to be Vite. Vite is going to be very fast and just installs the basic stuff that we need. All right. So how can we use Vite to create a new React app? Well, we can simply press this get started button and we're going to be redirected to this screen. Now, as you can see here, Vite, it's like the meaning of quick. It's very fast and it's a tool that allows us to, develop faster and create web applications like React. We also have vanilla, JavaScript or TypeScript, React, Vue, React, Svelte, and we have a lot of frameworks here. But the one that we are interested is going to be React with TypeScript. So let's select it. And this is going to take us here. This is just a demo of how Vite looks with TypeScript. This is using an online editor. So let's close this out. I'm going to leave this here and let's zoom out a little bit, keep scrolling. And this is the fun part. So to create a new Vite application, we can simply choose a package manager. If you don't know what is a package manager, basically it's the way you can handle the dependencies that you're going to be using on your project. My favorite one is going to be Yarn, and it's the one that we're going to be using throughout this course, but you are free to choose whatever you like. If you want to use NPM, just like that, you can do it. PNPM, it's a very popular and new one. And just as a side note, here we have another warning that is telling us that we need Node.js, so minimum version 14 and above. So we already have Node.js in our computer. We did that in the previous lesson. So let's go ahead and create a new Vite application using Yarn. So I'm going to copy this command, open my terminal. All right, so here I have my terminal and I'm on my desktop. So this is just going to be a simple example. And I'm going to paste this yarn create Vite command. Now, if you want to use Yarn, guys, you need to make sure that you have installed Yarn. And so I'm going to hit enter. And this is going to start creating my application, as you can see here, and it's going to asking me for my project name. In this case, it's going to be my first React app and hit enter. Now I want to use React, and here we have a choice of frameworks. So let's choose React. So this is going to be the first option. Hit enter. and that's it. Okay, so that initialized the project. Now we can simply install the dependencies by running yarn. And if we want to run these or start this development server, we can run yarn dev. Okay, so let's open this project on Visual Studio. And the way we do that is just accessing this, my first React app project, hit enter, and then we can open this on Visual Studio by running code dot. All right, guys, and this is how it looks. This is how our first React application looks like. As you can see, we have a lot of folders on the left side and configuration files. We have this vit.config.ts because we are using TypeScript. We have this configuration here. And also we have this package JSON that includes the dependencies that we're going to be using in order to handle this project. If you pay attention here, you're going to see that we have React and React DOM, which are dependencies required to use React, right? We also have dependencies that we are going to be using just on development, like TypeScript, types with React, types with React DOM. We also have some slint. So slint is like linters that allows us to catch errors or warnings when we are doing something wrong. Bit, and yeah, so we have these dependencies. But now if I go to my source folder and select my main.ts, you're going to see that this is going to be red. The reason for that is because we haven't installed the packages that we have on this package JSON. The way we install these packages is just opening the terminal and running the command yarn. Yarn because I'm using yarn, remember, but if you are using, for example, npm, you would run npm install or pnpm install. So let's hit enter. This is going to start installing all the dependencies needed to run this project. And also it's going to generate this node modules folder, as you can see here. This node modules folder, it's like a folder that contains all the dependencies needed for this project to run. And if I go back now to my app.ts or my main.ts, you are going to see that we don't have those errors anymore because we have installed React, React DOM client. We have installed all these dependencies so that we don't have any errors. Okay, so now let's run this project. We saw that the command to run this project is going to be yarn dev. But if you want to go back to the package JSON, you're going to see that we have these scripts here. And this script dev is going to start the development server. We also have this build, lint, and pre-built. So lint is going to run these scripts basically on the code base. For example, if we have something that is going against the linter or the syntax highlight that we have defined on this linter, we're going to find this error here. Now we're going to learn more about linters in the future lessons, but for now, let's just run this yarn dev, right? And this is going to start super quickly a server running on this link. So let's command click here. This is going to open my new React application, as you can see here, with Vite. Now, as you can see, this is looking super nice, and I can zoom this a little bit so we can see. And if I start pressing this button, stuff is going to start happening. All right, so the server is running, which means now if I go to my app.tsx, and we did something similar here when we were playing with Code Sandbox, we can come back here and just change this. Instead of being byte plus react, we can say my first React app and hit save. All right. Once we saved, this is going to be updated super quickly. And yeah, so we're going to see the difference and we can actually start developing our website. Okay, guys, and that's it for this lesson. I just wanted to show you the different ways that we can create a React application. And this is how we can do it. So now the application is running. So if you want to follow along creating your React application using Create React App or Next.js, you are more than welcome to do so. But for now, let's end up this lesson here. I don't want to move super quickly. Just wanted to mention that this is how we can create this application using Vite. And then we are going to start diving in more serious stuff. All right. So I hope you liked this lesson. I hope you learned something new. And I'll see you in the next one. Thanks for watching. Bye. Hello everyone and welcome back to Code with Beto. In this lesson, we are going to learn how to set up our GitHub account and also upload to GitHub our first React application that we created on the previous lesson. So let's get started. Okay guys, so here we have our first React application that we created on the previous lesson. But in this lesson, we are going to learn how to put this project on GitHub so that we can have a better control over new features that we add to this React application. Also, that is going to allow us to connect other services to this application like deployment or analytics by simply selecting that repository from our GitHub. Now, if you have never used GitHub, don't worry. This is the official page. And of course, I'm sure that you at least have heard about GitHub, but GitHub is the place where every developer, or basically the majority of developers, put their repositories. GitHub allows us to manage the new versions, adding new features to our project. And if we do something wrong, if we made a mistake, we can easily transition back to a previous version of the application and where everything was working. So GitHub allows us to manage the version system. If you don't have an account, create one. But I already have mine here, so I'm gonna go to my profile. This is how your profile should look like. As you can see, this is just my profile, and here we can start creating projects, all right? Now, before we actually create our first GitHub project to store our first React application, you need to install Git into your computer. So Git is going to allow us to basically put our code through the terminal to GitHub, all right? And before we start, we need to actually install it. And here are some couple ways, if you are using Linux, how to install it, also how to install it on Mac OS and also Windows. If you are using Windows, you can follow along these instructions. If you are using Mac, however, I really like just copying and pasting this brew install. If you have brew on your computer, you can just install Git by copying this command and put it in the terminal, and that should be all you need to do. Now, after that, you're gonna need to set up your credentials, but of course, I'm not gonna be showing you how to do that. I'm assuming that you already know or have at least the basic knowledge of GitHub. But once you have your credentials on your terminal, and also once you install Git, you can verify that everything is correct by just running git v. If you remember, we did pretty much the same thing to check the version of Node. And as you can see here, I have this version, and that means that I have already installed Git. All right, so once we have Git in our computer, we have just checked that we have GitHub, we can actually start creating a new repository. So to do that, let's go to GitHub. And here I'm going to create a new repo. So by saying new repo here, all right, this is going to bring us to this screen, and I'm going to put this on the right side. All right, guys, so on the right side, I have my GitHub, my new repo that I'm creating here, but I need to provide a name. So this is going to be with TypeScript examples, right? This is going to be the name of my repo. And then you can specify if you want this repository to be public so that anyone can see the source code, or private. In this case, we want it to be public, and they are going to ask us if we want to add a file, a README. Especially READMEs allow you to add descriptions to this project or tell a little more about your project to people that comes to this repository. But for now, let's just leave it like that. And if we go to the left side, you can see that we already have a README here because we used Vite. That's why we have this like information about this project. So we don't need that README. Let's create this repo. So I'm going to press this button here, and that's it. That's how we create a repository. Now we need to connect this new repository to our local development here. So once we are sure that we have Git installed in our computer, what we can do is just maybe close this Explorer, close these files, and open my terminal. I'm going to stop the server by pressing Ctrl+C and clear the terminal. All right, so I'm going to initialize a new Git repository. And they give you some commands that you can use here, like for example, git init to initialize this repo. So I'm going to say git init, right? And that is going to initialize this repository or a new repository in my directory. So nothing has changed here, but everything now it's green if you pay attention. And we also have this git ignore file. This git ignore, it's mostly used to prevent sending important stuff or important things that we have here, or things that we don't want to put on GitHub, like for example, the node modules, because the node modules are auto-generated when we install dependencies. And also these node modules, it's a huge, large file that we don't need. So we don't want this to be sent to GitHub. That's why we added to the git ignore, as you can see here. Now, another important thing here is that, for example, let's say that we have variables or credentials to connecting to an API, and we don't want to send that to GitHub. So in order to show this example, let's create a new file here. Usually we have these configuration files within a .env file. So for example, let's create a new one called API. All right, let's say that we have some API keys. So this is a place in where we would put that. So I'm gonna just write some numbers. And of course, we don't want this file to be sent to GitHub. So let's just save this and let's go to the git ignore. And in here, what we can do is just simply add this git ignore by saying .env and save. Now, if you pay attention, on the left side, this .env file, now it's gray, which means that GitHub is going to ignore it. All right, so now what I'm going to do, now that I have created and updated my git ignore, initialize my repo, I'm going to close this Explorer for now. Well, let's just leave it open because I want you to see that everything is green because we haven't commit anything yet to GitHub. So the way we start adding stuff to GitHub, once we initialize this repository, it's going to be by saying git add, and then I want to add everything. So if we put a dot, it means that we are going to be adding everything. But let's say that we just want to add the README. So we can simply say README.md or markdown. So if I press enter here, and then run the command git status so that we can see what's going on, you are going to see that we have this README here, but it's not committed yet. It's just added to this commit. And the way we add it to this commit is by saying git commit. So this commit basically is going to send the code that we have added, in this case, this README, to GitHub. Right? So if I say git commit and then passing the flag m, which means message, and the message that I want to commit is going to be add README, for example. Once we add the message, I'm going to press enter. All right. And as you can see here, we have some feedback that says that one file has changed. And if you pay attention on the left side, the README is not longer green because it's backed up on GitHub. Now, if we go to GitHub and reload, nothing is going to happen yet. The reason for that is because this local repository or this local project doesn't know that it should be sending this information to GitHub. And also we just commit some changes, but we haven't pushed them. All right. So as you can see here, we have this like branch that basically sets the branch that we want to send this code. I'm not going to be explaining what is a branch, but basically it's like a section of the code that we're going to be working on. Okay. So if you pay attention here, they are saying main, and we already have the main here. So that means that we are working on the main branch. Now we need to add this, this origin. So I'm going to copy this line and paste it here. Basically, we are saying that the remote origin to this application is going to be this link that you can copy here or just copy here. So if I hit enter, now my local project knows that is connected to this specifically repo that we just created. Now, in order to push this, we can simply say git push, enter, and now I'm going to have an error now. Well, it's not an error, it's just like a warning. It's telling me that nothing happened because we haven't set up an upstream. And the upstream is going to be to the main branch. So we can simply copy this, this line of code here, copy and paste here, hit enter. All right. And we need to do that just once. Just set the upstream to this origin main. And if I reload now this repo, you're going to see that we have one file. And if I press view code, the only thing that we have sent to GitHub is the README. All right. And we have this README that looks like this. All right. Now I'm going to clear my terminal again, and I want to add everything in this case. So I'm going to say git add dot git commit, then first commit. All right. This is a message for this commit. And finally, we can push this. Once it's committed, as you can see, it changed to be, normal color. So now we can simply say git push. If I say git push, clear my terminal, go back to GitHub and reload. View code, you can see that now everything is on GitHub. And you can see the commits that we have created. In this case, we have only two. The first one was 3 minutes ago, and the second one was just now, which is really nice, and we can keep track of this. Now, let's say that we made a mistake. GitHub allows us to go back to that, to the previous commit for saying, all right? And yeah, this is how you can keep track of your changes. Now let's go to the code. Let's say that we want to change the README. So let's go to the README and just basically delete everything that we have here and change this to be just a header that says example. Hit save. Now, because we changed this file, now it's yellow, as you can see here. And if I say git status, you're going to see that we modify the README. So let's add it. I'm going to say git add all. And if I run git status again, it's going to be green, but we need to commit it. So I'm going to say git commit. And this message is going to be update README. Update README. And then git push. All right. So if I clear my terminal, go back to GitHub, you can see that now the README has changed just to be an example. And if I view the code, specifically on the README section, you can see that just now we updated it. So this is how we keep track of the code, guys. If you want to share this code with someone else, you can just simply copy this link and send it to them. But yeah, that's it for this lesson, guys. I just wanted to mention how you can quickly set up a new GitHub repo for the project that we're going to be working on. This is going to be very helpful in the long run and allows you to keep track of all your changes and all the new features that you are adding to your project. I hope you like this lesson. I hope you learned something new, and I'll see you in the next one. Thanks for watching. Bye. Hello everyone, and welcome back to Code with Beto. In this lesson, we are going to learn how to deploy our first React project that we created on the previous lesson. Now, at this point, we have this very first React application. We haven't dived into the code, but it's running, and also we have it on GitHub. So let's actually deploy it. You're going to be surprised of how easy it's to deploy a website nowadays, especially using modern tools like Vercel. So let's dive in. Okay, guys, so here we have our first application, our first website using React, and we haven't changed anything. But if you remember, we put this on GitHub, so now the code lives here, and you can see the commits that we have here, and the README, and all that stuff. All right, so how can we actually deploy these websites so people all around the world can come in and use our website? Well, for that, we're going to be using Vercel. It's worth noting that there's a lot of services that allows us to host our websites, but I think Vercel is the one that we should use, especially if you are not familiar with anything else. You could use, for example, AWS, you could use Google, but Vercel really provides a really nice developer experience and makes it super easy to deploy these kind of applications. So let's actually create an account if you don't have one already. As you can see here, I'm already signed in. This is my account. So let's go to my profile. So I'm gonna go to my dashboard here. You can see some of the applications that I've been working on. And if I do this a little bit bigger, of course, you are not going to see anything here. If this is the first time that you have created your Vercel account. But once you have created your account, you can simply create this add new button, select project, and then you need to connect your GitHub account if you haven't already. But as you can see here, I have all my repositories that I have on my GitHub. So if I select React with TypeScript examples, and by the way, Code with Beto 2.0 is this platform that you are using. So yeah, I use Vercel and it's really good. I'm happy with Vercel. It's a really good developer experience. So that's why I would like to recommend it to you guys. So let's select the React with TypeScript example and import it. Now here we just need to specify the framework or preset that we are using. In this case, we are using Vite, as you can see here, but we could also use other frameworks like Vue, and we have a huge list here. And usually Vercel detects the framework, so we don't need to select anything, just deploy, right? Now let's wait a little bit. And that's it, guys. That was super quick. This is how we can deploy an application using Vercel. Now we can select here, and you can see that we have this React with TypeScript link.vercel.app, and we can start actually sharing this link with people, and they are going to be able to visit this website. All right, let me just make this a little bigger so that we can see what's going on and everything is working just fine. So that's it, guys. This is how we can actually deploy. And also a cool thing to know here is that if I go to my dashboard and select this React with TypeScript project, we can set up more things, like for example analytics. You can enable analytics if you want, so that you can see how many people are in your website, how are they using your website. This is a really good feature. Also deployments. So now every time, because we connected Vercel with our GitHub, every time that I change something on the code, for example, if I go quickly to my app and let's change that, and instead of my first React app, we just want to say my React app. So let's say git status super quickly, git add, git commit, and we can say change. Of course, you want to name your commit better. So next, git push. Now Vercel, it's going to detect that we just push something to the repo, as you can see here, and it's going to start deploying this project again with the latest version. So this is going to be, I hope this is going to be quickly. Okay, so that was super quickly, 9 seconds. And if we go to the link and reload, you are going to see that now we have the new version. So this is the power of Vercel and using GitHub. And yeah, so let's say that we made an error and we want to return to this commit. We can simply select these 3 dots and select instant rollback to go back. If we made a mistake, this is great. This is a huge developer experience, super nice. It took like 2 or 3 minutes. So this is crazy. But yeah, this is how we can deploy your application, guys. I hope you like this lesson. I hope you learned something new. I hope you had fun, and I'll see you in the next one. Thanks for watching. Bye. Hello everyone and welcome back to Code with Beto. In this lesson, we are going to learn the basics of TypeScript. We're going to learn as well the basic types that we can use with TypeScript and how we can compile TypeScript code. So let's get started. Alright guys, so as you may imagine at this point, the first thing that we need to do before we can actually use TypeScript is install it in our computer. There's a couple ways in which we can install TypeScript. One of them is using npm, and the other one is just downloading and installing the executable. In this case, we're going to be using the npm package. So if I just run this on my terminal, npm install global TypeScript, remember that you need to have Node.js in your computer. So let's go ahead and just run this. Just as a side note, this is we are passing the global flag here. This means that we're going to have available TypeScript globally in our computer, which is good. It doesn't really matter. It doesn't really affect us. So let's go ahead and install it. All right, so that was super quick. Once we have installed TypeScript in our computer, we can always put the name of the package. In this case, it's going to be TSC, which stands for TypeScript compiler. And then we can pass the flag v to check the version. As you can see here, at the time that I'm recording this video, we have the version 5.1.6. And that's it, guys. Now we are ready to go and start using TypeScript. So let's jump to VS Code and actually start creating our first TypeScript program. Okay, guys, so here I have VS Code opened. And the first thing that I want to do here is this is just an empty folder. I'm going to start by creating a new file, and I'm just going to name it hello.ts. We are going to put TS because in this case we want to, write TypeScript. That's why we need to specify the extension TS. Automatically, VS Code is going to detect that this is a TypeScript file. So let's go ahead and just create our first variable here. I'm going to start by declaring a variable let's, and I'm going to name this hello, and this is going to be equal to a string that is going to say hello. Then we can put this on the console by saying console log and passing hello. All right, this is very basic. And at this point, we haven't really typed any TypeScript. This is just regular JavaScript. But I want to mention, guys, that if you remember, we installed Node in our computer, and if we want to compile this code, we should be able to simply say Node and pass the name of the file. In this case, it's going to be hello.ts. And if I hit enter, you can see that we have this console log that is running. But I want to mention something really important, guys. Node.js, it's a JavaScript runtime that only supports JavaScript, right? But in this case, we are writing TypeScript. So how is this working? Well, like I mentioned before, we haven't really used TypeScript in this program because we haven't declared types. Remember that TypeScript is going to allow us to specify the types. In this case, we are using a string, right? And if I hover over this variable, you can see that we have the type that TypeScript is inferring by just initializing this to this string. But if I delete this and I do hover again, you can see that now it has an any type. So let's put that back and let's just say that this is a string and hit save. All right. Now we are using TypeScript syntax here. And if we try to run this again using Node, Node is for compiling JavaScript. Let's try to run this. In this case, we are going to have an error. The reason for that is because we are writing this syntax that is not from JavaScript, right? We are using TypeScript. That's why we cannot compile or run this using Node. And this is what I want you guys to take home. TypeScript is just a language that is going to allow us to add types. The reason for why we need to add types here is because when someone else comes and reads our code, they're going to see that this is a string and it's going to be more easy to read, easy to maintain, and also it's going to prevent us to make mistakes. For example, if I come here and just grab this hello and say this is going to be equal to 10 at this point, TypeScript is going to start yelling at me, as you can see here. And if I do hover here, you can see that type number is not assignable to a type string. We declared that this was going to be a string. So if I was making a mistake, I am able to catch it early here and maybe change this to be a string. And now everything is going to work fine. But now how can we run this code if Node.js doesn't recognize TypeScript? Well, the way we can run this code is actually compiling this code. So remember that we installed TypeScript. That means that we can use TSC and then passing this hello TS, it's going to compile this TypeScript file to a JavaScript file. If I hit enter, you can see that now here we have suddenly this hello.js. And what happened is that TSC took this TypeScript file and compiled it and translated it to plain JavaScript. As you can see here, if we put this side by side, you can see that we don't have here the string type. We don't have spaces between lines. This is just the JavaScript plain file. Now we are able to say node and then say hello.js in this case, because we know that Node.js only runs JavaScript. And if I hit enter, you can see that this is working perfectly fine. This is very important to realize, guys. At the end of the day, once we compile our TypeScript code, it's going to be translated to JavaScript, because this is the language that Node.js handles and also the browser. The only difference is that TypeScript is going to allows us to develop better and more reliable applications. So now that we know that TypeScript is going to end up translating whatever we are doing to JavaScript, let's actually talk a little more about what kind of types we can use with TypeScript. So what I'm going to do is just close my terminal for now, close this JavaScript file, and also delete it for now. All right, so we don't have this error. All right, so now I want to talk a little bit, guys, about the types that we can use with TypeScript and JavaScript. And if you know, for example, when we are writing JavaScript, the way we can declare the type of a variable, well, JavaScript is going to infer the type just by looking at what we are using to initialize this variable. In this case, we are using a string. But if we just say that this is a number like this, at this point, this is going to mark me an error. But if I delete the type, now if I do hover, this is going to grab a number. This is one of the many types that we can use with JavaScript and TypeScript. So TypeScript allows us to use the same data types. In this case, we can say this is a number. Then we can grab another variable and say, for example, my string. We already saw this before. And if I do string, we can pass a string like hello. Then we can also declare, if you come from another programming language, you may have seen big ints. And we use big ints when we have large numbers. Let's say that we have a super large number, and I'm going to initialize this, and I'm going to put a lot of values here. So this is a super large number. And if I do hover here, you can see that this is a number. But this can lead to bad performance. Thankfully, we have this big int type, as you can see here. And now this is yelling at me because type number is not assignable to a type big int. The reason for that is because big int needs to be initialized like this. Big int, and then we pass the number. So let's just grab this and put it here. Now, if you pay attention, we have these three little dots. The reason for that is because this is not going to work yet. We need to specifically tell that this is a big int number by putting an n here, or we can just put this on quotes like this, right? And this is going to be a big int now, right? And if I delete this type, it's going to infer that this is a big int, as you can see here. All right, so let's put this big int again. Okay, so at this point, we have three data types. I'm going to close the Explorer so we can see better here. I'm going to declare another variable. In this case, I'm going to say this is a constant variable. Now, if you are familiar with JavaScript, you know the difference between let and const. These are just ways in which we can define a constant variable and a variable that is going to change, which would be let, right? So let's declare now another. This one is going to be a Boolean. It's active, and let's say Boolean. We can initialize this to be false as well. Boolean, it's a very important type and very widely used. Then we also have symbols. Symbols are mostly used for keys. So we can say unique key for this variable, and we can initialize a symbol by passing this initializer symbol and then the description. In this case, could be description like this. And yeah, so if I hover this unique key, you can see that this is type of unique key, which at the end of the day, it's a symbol. Okay, that is another kind of type that we can use. And this is mostly used, for example, when you are dealing with objects. Let's say that we have an object here, and objects have keys, right? So in this case, I can say key, my key is going to be hey, and then we provide a value here. But these symbols are widely used as keys. So we can say unique key. And now this should be working fine. So you usually want to use a symbol when you don't have a numerable key and you need like a unique key, right, for this object. Now I'm going to delete this object. Let's pass to the next example. The next type of data that we can use, it's going to be null. And this is very simple. We can say empty value, and we're going to be using this null a lot. This is how it looks. And the type, as you can see here, it's type of null. We can copy this and paste it here. And if I do hover here, you can see that this is type of unique key. But at the end of the day, this is a symbol, so we can say symbol, right? Okay, so that is null. And you want to use null when you want to explicitly indicate the absence of a value, right? And then we have another one that is undefined. And to see this example, we can declare a variable that is not going to be initialized. So uninitialized value, and just leave it like that. So if we don't initialize this variable, this is going to have any, but this will be the same like saying undefined here. And the undefined value, it's typically used by the system to indicate uninitialized variables or missing properties. Okay, in this case, because we haven't initialized this is going to be undefined or any. Now, if we try to do basically the same, but with a constant variable, let's say my var, and just put it like that, this is going to mark me an error because this is a constant variable, and constant variables must be initialized, as you can see here. So we need to initialize this to some value, let's say 10, and yeah, that's it. But in this case, let variables don't need to be initialized. That's why we don't have an error, but this is going to be of type undefined. Now, finally, let's go to the final type example, and this is going to be object. So let's declare an object. Let's say person, and person is going to have a name, which is going to be, let's say Bob, and Bob also has an age of 30. All right. Now, if we do hover over this person, you can see that we have like inference from TypeScript, and it's inferring that the name is going to be a string and the age is going to be a number. Basically, you want to use an object whenever you need to group related data or represent complex structures, in this case, a person. And this could have more properties, for example, address and stuff like that. All right, let's just delete it. Now, if you want to specifically type this person, like we have done here, we could say, for example, colon, and then open an object and start typing the properties. So I'm going to say name. Name is going to be of type string. And then we can say age is going to be of type number. Now, if I hit save, this is going to just work the exact same way. But let's say now that this was supposed to be a string. And if I hit save, now we are going to have an error because we are setting a number and TypeScript is letting us know that this should be a string. So we can catch this bug early and just put it a string, and everything is going to work before we can actually compile this code, which is pretty nice. Now, before we go, guys, let's just compile this code to see the output. I'm going to open my terminal, tsc, and then pass the name of the file, in this case, hello.ts, and hit enter. All right. And as you can see, we have two errors. The first one is that we cannot find begin, and the second one, we cannot find symbol. The reason for that is because we need to set some compiler options when we are dealing with this kind of types. But let's just for now, don't worry about that and just comment these two, right? And let's put this up and try to run this again. All right, and everything went well. If I open my Explorer, let's close the terminal now. You can see that we have this code that has been compiled, and this is how it looks when it's compiled. So pretty nice, right? Now we can actually pass this hello.js to the browser or to Node.js, and this is going to work perfectly fine, safely typed. And that's it for this lesson, guys. I hope you like it. I hope you learned something new. I encourage you to learn more about the basic types that you can use with TypeScript. And otherwise, I'll see you in the next lesson to start seeing more complex stuff with TypeScript. Thanks for watching. Bye. Hello everyone and welcome back to Code with Beto. In this lesson, we are going to learn more advanced types that we can use with TypeScript. So let's get started. All right, guys. So let's start with the first type that I want to mention, and it's going to be arrays. the way we can type arrays, right? And maybe this was one of the simple types that I forgot to mention on the previous lesson, but I think it's a little more complicated than the basic ones. So let's see how can we type an array. Let's say that we have an array of numbers, and this array of numbers is going to look something like this. It's super easy, actually. If we just make hover over these numbers, you can see that TypeScript, it's most of the time going to give us the type that is inferring from this variable. So we can actually just grab it and put it here. And this is how we can type an array. This is a very good way of typing this array. We are basically saying that it's an array of numbers, but there's another way that we can use to type arrays. So let's say that we have an array of names, and we can also say, well, if I just put an array of names like Alice, Bob, and then maybe Beto. In this case, if I do hover again, you can see that it's basically the same syntax, but in this case, they are strings. But another way, it's using the interface array, as you can see here. This interface is going to take one argument, as you can see, and this is like a template. So let's put it like this. Now we need to specify the template, right, that we want to use. In this case, the type that we're going to be using for this array. In this case, it's going to be string. This is another way that we can use to type arrays. Now, if I change this to be a number, we would get an error because these are strings, right? All right, let's pass to the next type, and these are going to be enums. Enums are one of my favorite features that we can use with TypeScript. Enums are like constants that are likely to never change, and we are going to have like a couple. For example, I like to use enums when I'm dealing with dark and light mode. Now, because everyone expects your website to have a system setting as well. So in this case, we will have dark, and we would also have light and system. And then we're going to be validating between these values to render the UI necessary. Okay, so we can easily create an enum that can be named dark mode, for example. And this dark mode can have 3 values, right? I'm going to say dark, then it can also have light and system. Then we can simply use this by saying const theme, and then we can set that this is going to be of type dark mode, and then we can initialize this to be, for example, dark mode dot light, right? Now we know that this is going to be light, but the value in this case is going to be 1. Now, by default, the TypeScript is going to assign numbers to each value, and if I do hover over light, you're going to see that it's 1. And if I take dark, this is going to be 0. If I hover, you can see that this is 0. Now, one interesting thing to notice here is that we can also initialize this to be, for example, 1. And now TypeScript is going to assign 1 and then 2 and then 3. Let's try this out. You can see this is 1. Then if I change to light, this is going to be 2. And let's say that we want to initialize this to be 10, just to see what happens. If I do hover here, you can see that this is 11. So TypeScript is going to be auto increasing. Now, I don't really like having to assign these numbers here, but it's a good practice to provide a string value to these values. So let's say dark is going to be dark, and we're going to do the same with the system. And if I hit save, now let's go to the value here. You can see that now this is a string. This is more easy to validate and use. Now, if we want to validate, for example, depending on the value of the theme, we can say if theme it's equal to, and then we can use the enum and say if it's equal to light, we can say console.log light. And this is how we can use enums, guys. So this is going to keep the code cleaner and very easy to understand. Now, moving on to the next one, are going to be interfaces. And maybe you have heard about interfaces. They are widely used on TypeScript, especially on React development. And basically an interface, it's another way to declare an object type. And the way we do that is just by saying interface, and then we can have something like user, for example. This interface is going to be for a user, and a user can have values like, for example, ID, that is going to be a string, can also have a name of string, age of type number, for example. And then the way we use an interface could be, for example, declaring a user in this case, let's say user, and the type is going to be user, right? And then we can initialize this to be an object. And if I press Command I, I'm going to have autocomplete, and we have all the fields that conform this user. And let's select the ID and initialize these values to be, for example, 1, and then name can be Beto, and then age can be 10, for example. All right. Now, if you notice, if I don't put the age, for example, TypeScript is going to start yelling at me because property age is missing. Now, one way to fix this is making this age optional by putting a question mark. Now, this is optional, which means this object could come with age or not. In this case, because it's optional, TypeScript is not yelling at me. If we don't provide the question mark, name and ID are going to be required in this case. Now, if I just leave this like that, TypeScript is going to give me an error. Now, something very similar to interfaces are going to be type aliases. If you remember in the previous lesson, we saw objects, right? For example, we have something like car, and that was an object that has, for example, brand, that is a string. So we can say maybe Toyota, and then year, and this is going to be, I don't know, 2020. And if you pay attention, guys, when we hover, we can see that TypeScript is generating this type, right? But what we did in the previous lesson was just simply copy this and paste it here. And this is how we can type this car. But this is not very easy to read and also not very scalable if we want to reutilize this type somewhere else. This is where type aliases come in. The way we can declare a type alias is going to be just by saying type and then saying type car in this case. And this is going to be equal to an object. And then we can put these things inside this object. And then instead of having this huge object here, we can simply say that this is going to be of type car. Now this is looking really similar to interfaces and type aliases. And they are very similar, but there's a couple differences. The first difference is the syntax. As you can see, we need to say type and then equal to a new object. And interfaces are going to be just naming the interface and opening curly braces and start defining the types. Another difference is that when we are using interfaces, we can extend to use another interface. So for example, let's say that we had another interface called human or maybe person, and a person has a birthday. So we can say birthday and then put the type of string. Now we can extend this interface of the user with the interface person. The way we do that is just by saying extends here, then pass person. Okay. And now if we use this on a variable, let's say user, and pass the type user, if I show my autocomplete, you can see that we have this birthday property that the user alone doesn't have, as you can see here, but because we are extending, we can use this property on this user. That is really nice, and that's a cool feature that we can use with interfaces. But we can do also something similar with type aliases. Let's quickly change this, delete this, and I'm going to change this type alias to be animal, for example. And an animal can have a name. So this name is going to be of type string, and then we can declare another type down here. This is going to be a dog, and a dog can have, for example, an age of type number. The way we can extend in this case using an intersection, it's going to be just putting the type that we want to extend and then put an ampersand. So this is basically intersecting these two types. And now if we declare a variable, let's say const my dog and pass the type dog, this is going to be equal to, and if I show my autocomplete, you can see that we're going to have age and name because we are intersecting these two types with this ampersand, okay? This is a little more complicated, but this is how we can extend the functionality of a type. So what is the difference between an interface and a type? Basically, they are almost identical except for the syntax. And also another thing is that we can add fields to an existing interface. So let's say we already declare person, but we want to change it somewhere in the program. I can say interface person again, and then open my curly braces. And let's say that we want to add another property like height, for example. And now let's try to use this interface again. So let's say user of type user and equal to, and if I show my autocomplete, you can see that now we have height. So we basically created another interface with the same name, but TypeScript detected that this interface, we had it before and simply added this field. So this is very powerful, and we actually cannot do this with type aliases. Once we create the type alias, we cannot change it, but in this case we can, which is really nice. Now let's try to do the same here. If I try to say type animal, open curly braces, and add something like age number, and if I put an L here, you're going to see that because they have the same name, TypeScript is going to start crying and it's going to tell me that this is duplicate identifier animal. Okay, so we cannot do the same with type aliases. And basically that's the only difference. So in conclusion, with interfaces, we can add properties after we have created these interfaces, and also we can extend, right? This is a more elegant syntax to me. I prefer interfaces in this case when we are going to extend from another interface. And I find this intersection to be a little more confused. But at the end of the day, they do almost the same thing. All right, guys. So moving on to the next one are going to be literal types. These literal types, the way we can declare them are like this. Direction, for example. And this is very similar to an enum, I would say. But we want to use literals when we have values that are not likely to change, and we don't want to confuse them in this case for a string, for example. Let's say that we have north and we have south. So I'm going to say south, and this is how we can use type literals by putting this pipe or vertical bar. We are basically saying that this direction is going to be of type north or south. But pay attention, guys, that this is not going to be a string. So for example, if I say direction, this is going to be a variable of type direction. And if I say that this is going to be equal to north, everything is going to work fine. And the cool thing about this is that when we are managing this direction, we can simply have validations like this, and we are going to have this really nice autocomplete. In this case, we can validate if this is equal to north, or we can also say, for example, if we change this to be a let, so we can reassign it, we can say direction equal to, and if I just open quotes, we're going to have this really cool autocomplete and we can reassign it. But if I try to say something like east, TypeScript is going to start yelling at me because we can only assign these values here, right? And if I do hover here, you can see that this is not assignable to a type direction unless I copy this and go and add it using a literal. And now this is going to work just fine. Of course, if we try to change this to be a const, it's going to yell at us because we cannot reassign constant variables. The next one is going to be intersection types. And we already saw a little bit how we can use intersection using types. Basically, we just declare a type, for example, this type. And then we can declare another type, B, that is going to have another property like number. And if I hit save, then we can create another type alias and say that this is going to be my type C. And we can have an intersection between A and B by putting an ampersand like this. Okay, now I can say const value, and this is going to be of type C, which is my other value. And if I just put open curly braces and autocomplete, you can see that now we have these two properties. But what happens if, let's say that we had A here of type number? Let's go to the autocomplete here. This is going to be A and B as well. But let's try to add this as a string. And now this is going to start yelling at me, and B is going to be a number. But TypeScript is going to start yelling at me because A is not assignable to a type never. Now, something weird happened here because we have this intersection and they have the same properties with different values. Let's try to change this to be a string. Now the error is going to disappear. Intersections are very useful, especially if you want to combine complex types and you don't want to rewrite them over and over again. You can basically intersect some types that reutilize another fields that you need. Moving on, I want to talk about the type assertions and casting. So in TypeScript, we can assign a type to a variable that we don't know the type yet. So for example, let's say that we have a const variable that is some value, and this is of type any, which means we don't have a value for this, and we can say this is a string, right? But we specifically said that this was going to be any, so it's going to stay any. And now let's say that we need a variable that contains the length of a string. And the length of the string is going to be a number. And I want to have the string length of this value, right? So I can say some value dot length. Now, if you pay attention, I don't have autocomplete here because TypeScript doesn't know that this is a string, so that we cannot access the JavaScript methods like length, right? So what we can do is just casting this into a string. So I'm going to say as string, and now I'm going to have, by just putting dot, I'm going to have autocomplete, and I can access all these methods from JavaScript. So I'm going to say length, okay? And this is going to work just fine. This is how type assertion work in casting, and they are useful, especially if you are getting a value that you know the type. For example, in this case, we know that this is a string, so we can say as string, and we could also do something like as user. In this case, we can access, I don't know, the ID, for example, and yeah, and do stuff more complicated like that. And then just the final type is going to be any. I just want to mention that this was introduced to escape the hatch from TypeScript type system, but obviously it's not very recommended to use any all the time. Use it carefully and always try to type your variables. So that's it for this lesson, guys. I'm going to leave you some examples down here, and I would encourage you to read more about these a little more complex types on the TypeScript documentation, or just play around based on these examples that we just saw. That's it for this lesson. I hope you like it. I hope you learned something new, and I'll see you in the next one. Bye. Hello everyone, and welcome back to Code with Beto. In this lesson, we are going to master functions with TypeScript. So let's get started. All right, guys, so here we are on VS Code, and the first thing that I want to teach you is going to be basic functions. So normally when we are writing JavaScript, we declare a function by saying function and then the name of the function, for example, do something. Now, when we are using TypeScript, we need to specify some things, because if I do hover over this function, you can see that we have the type, the return type. In this case, it's going to be void. And of course, we are not receiving anything here. But for example, let's say that this is going to return just a string that says hello. So at this point, we are just using TypeScript inference. And if I do hover here, you can see that now it's returning a string. But it's a good practice to type this here. So in this case, I'm going to say that this function is going to return a string. And also, let's say that we're going to receive some parameters. So I'm going to say A and V. And we cannot leave this like that, because if I hover over this, we can see that this value implicitly has an any type, right? So let's type this out. I'm going to say that A is going to be, let's say, just a number, and B is going to be a number as well. So we can say something like result equal to, and then we can add, for example, A plus B, and this would work just fine. To see this in action, let's compile this code by saying tsc and then hello. All right, this is going to create the JS files you can see here. And if I select it, it's going to be just without types, right? Now let's try to run this using Node. I'm gonna say Node and then hello.js. And if we hit enter, nothing is going to happen, because at the end of the day, we are not even calling this function. So I'm just gonna say console log do something and pass maybe 2 and 5. Now let's try to run this again. And we have the result, which is 25. But if you pay attention, guys, this is just concatenating these two numbers. So this is not really working. So what we can do here is actually try to add these values before we concatenate them. And then I'm going to add the console log here. So I'm going to say do something, passing, of course, 2 and 5, for example, hit save. Let's compile this again and let's run the node.js. So I'm going to say hello.js and the result is 7. So in this case, because we put this in parentheses, we are actually adding these two numbers and everything is working just fine, right? So the result is 7, as you can see here. And that's how we can type basic functions. Of course, we could do something more complicated. For example, let's say that we have type complex type, and we have, for example, some things like name, string, and stuff like that. We can simply type these values with the complex type here, and everything should work the same way. Of course, we need to, handle these types inside this function. Otherwise, TypeScript is going to mark an error. But yeah, this is how we can use basic functions. So let's keep moving on. I'm going to just add a space here, and I'm going to copy this function. And what I want to talk about is going to be optional parameters. I'm going to paste the same function here, and I'm going to change the name of this function for maybe optional. This function is called optional. And what I want to mention is that sometimes we are going to have as well optional values here. So let's say that v can be optional, which means that TypeScript is going to expect this v to be either number or undefined. And now, because we just marked this as optional, it means that this v, it's possibly undefined, as you can see here, so that we can handle this better. And in this case, we need to do something like, for example, if we don't have a v, maybe return just an empty string. And we are returning early in this case, in the case that we don't have something. But now, because we marked this as optional, TypeScript let us know that we needed to add this handle here. Otherwise, we could have an error on production. So now if we provide this value, we are going to pass this if statement and we are going to return the result. And this is how we use optional parameters on functions. Now, moving on to the next one, I'm going to declare another function. And the next one is going to be default parameters. Default parameters, I'm going to rename this to be default parameters function. And for example, in the case that we don't want to have this handle, in the case that it's undefined, what we can do is provide a default value for b. In this case, I can say if the user of this function is not going to provide a v value, what we can do is actually initialize this value to have a default value. All right, so let's say that we want to have default 10, but now TypeScript is marking me another warning here, and it's telling me that the parameter cannot have question mark and be initialized, right? Because if we don't provide this v, it's always going to have this 10 value. So let's just delete this question mark and everything is going to work just fine. And now if, for example, if I don't provide this v, TypeScript is just going to initialize it to be 10. Let's just say default parameters and then pass just 10 as the first number. And v by default is going to be optional because we have initialized its value to be 10. Let's quickly test this out. I'm going to say console log and then put the return value on the console, which in this case should be 20, right? So let's save this. Let's open the terminal and let's compile this again, running TS, and then I'm going to run the hello world using Node. And the result is 20 as we expected. And this is how we can use default parameters or default values on functions. Now, moving on to something a little more complex, we also have call signatures in TypeScript. And basically, these signatures allows us to describe functions types without giving it a specific name. So let's say, for example, that we have an interface, and this interface is going to be, for example, math operations. And we want to define a signature for a function. So this function is going to take two parameters, x and y, and then it's going to return some value, right? So the value that is going to return its number, so that these values or these parameters are going to be number as well. And then this is going to be number as well, right? And if I hit save, this is how we can create a signature for a function. But the cool thing about this is that we are not giving it a name, which means that this type can be reutilized for a function a couple times or more than a couple times. And how can we use it? Okay, so let's now define a function, and this function is going to be called add, which is going to add two numbers, right? And the type is going to be math operations, as you can see here. And this is going to be equal to, if I open parentheses here, we are going to see the signature that we need to use for this function. So we know that the signature is going to receive two numbers and it's going to return a number. So we can do whatever we want with these parameters, right? So let's grab A and V, which is value 1 and value 2, and return, in this case, the sum of these two values. All right. Now let's say that we want to do something similar, but in this case, we want to subtract. So what we can do is simply reutilize the same signature that we had before and say AV, but in this case, I'm going to say A minus V. So in this example, math operations, this interface that we create here, has a call signature that describes a function taking two numbers and returning a number. Any function that matches this signature can be assigned to a variable with the type math operations. So these functions are matching this signature. That's why we can reutilize this interface over and over again as long as the signature complies with these values. This is very useful if you want to enforce that a set of functions have the same signature, or when you are working with high order functions that accept functions as parameters. It helps in maintaining consistency and can make the code more robust and understandable. Now, moving on to the next topic, I want to discuss higher order functions. And basically these functions are functions that take other functions as parameters. Let's see how can we define one. I'm going to declare a function called higher order, for example, and then this function is going to take a function as parameter. So I'm going to call this parameter func, and the type is going to be of function, right? So we expect a function, and in this case, we could use a call signature, but we can also define the signature or the type of this function by putting it like this. Let's say that this is going to return a number, and it's going to take two arguments, A and V. Remember that we need to specify the type, so they are going to be number both. And on top of this function, maybe we can say that we are going to get other values. So I'm going to call this other. It's also a number, and that's it for now, right? Now we can use this to return this function. So this function is going to execute this function, and it's going to return the execution of this function. So let's call func, but remember that func, it's going to take two arguments, A and B, and it's going to return a number. So I'm going to say that the first number is going to be other, and then I can just write another number, in this case 10. Okay, now if I hit save, and if I do hover over this function, you can see that it's going to return a number. And instead of inferring this, we can just put it here as return value. Let's try to test this out super quickly. I'm going to say higher order, and I'm going to pass a function. All right, so the function that I'm going to pass here could be a function that we can create here. So this function is going to be divide, for example, and divide is going to take a number and the number, and it's going to return a number as well. Now at this point, TypeScript is yelling at me because we are not returning a number. So let's return a number. I'm going to say return A divided by B. Okay. And now we can use this function here. So I'm just going to copy and paste it here. And remember, guys, we have other value here, and we are missing this other value. So the other value in this case, I'm just going to provide, let's say 10. So what we are doing here, it's called this higher order function. This function, it's going to basically call this function with 10 divided by this parameter that we are passing here, this other. So in this case, we should expect number 1 as result. Let's try this out. I'm going to say TSC and then compile this hello. Oops, and I forgot to put TS, right? And then just run the JavaScript file by saying hello node.js, and the result is 1, as you can see here. Let's try to change this by 100 and quickly open the terminal, compile this again, and then run it using node. So I'm gonna say node hello.js. And now it's 10. So 100 divided by 10, it's 10. And this is how we can use higher order functions on TypeScript. And if you want, guys, we instead of having this division here, what we can do is just comment this and just write a function here that basically is going to take the same values A and B. So I'm just going to copy here and put it here. And this is going to return A divided by B. And everything is going to work the exact same way. But in this case, we are defining this function in line. Let's try to run this again. And we have the exact same result as you can see here. Now moving on to the next topic, I want to talk about other types that we can use. And maybe you have seen or you are going to see when you are using TypeScript. And the first one is going to be void. Void represents the return value of a function which doesn't return a value. And I think we saw this already, but let's just create a function here, call it return void, and just return like that. Now, if we hover over this return void, you can see that this is void. And basically, guys, void just means that this function it's not going to return a value, and it's going to be inferred by TypeScript every time that a function doesn't return anything, or in this case, we just have this return, but if I don't provide this return, it's going to be also void. Now, void is useful if you are going to do something, for example, some actions, in this case, console log. We can just console log, and this is not going to return anything. It's just going to perform this action to put something on the console. So if I do something here, this function is going to be as well void. And it's good practice, just mark it as void here. We could also do this with an arrow function. Let's say return void arrow. And if we just open curly braces, we can hover over this return void arrow function, and you can see that it's returning void because we are not returning anything. And we could put the signature here or the type of this function here. I think this is a little more confusing in this case because we have like this definition that looks almost the exact same way as this. But yeah, we are saying that this is going to return void because we are not doing anything at the end of the day, and we could just copy this console log and put it inside these curly braces, and everything is going to remain the same way. Now moving on to the next type that I'm sure that you are going to see at some point when you are using TypeScript, it's going to be unknown. And this type is similar to the any value. If you remember, we have seen this any. We try to avoid any, but it's safer. Unknown, it's safer because it's not legal to do anything with an unknown value. And to see an example, let's create a function. I'm going to call this function any function, and it's going to take a parameter of type any. Let's say that it's an object that has, for example, a field called name, right? Now, in this case, TypeScript is not telling me anything because this is any. So which means that it could be, which means that this could have a name value, right? But we are not going to know until we run this code. But when we are using the type unknown, so I'm going to call this function unknown function, and this function is going to get a value as well. And in this case, it's going to be of type unknown. And now if we try to access the same value on this unknown value, TypeScript is going to start yelling at me because A is of type unknown. And like I mentioned before, it is not legal to do anything with an unknown value, right? In this case, we're going to get an error, which means that using unknown is safer. But for example, you can just return this a unknown value, and you can do so. But if you try to add, for example, let's say 10, now we're going to have the same error because this is unknown value and we cannot do anything with something that we don't know what it is, right? So in conclusion, any and unknown are the same, but unknown it's safer. Now the next one is going to be never, and never it's used when a function it's never going to return a value. Let's see an example. I'm going to create this function never return value, and this is going to return never. So never types represent values which are never observed in a return type. This means that the function throws an exception or terminates the execution of the program. And if I do hover here, you can say that a function returning never cannot have a reachable endpoint. So it's useful, for example, if you are going to throw a new error. In this case, this is valid because we are sure that this function is going to throw an error. So basically, it's never going to return anything, just an error. But never, it's a bit trickier. Let's create a function called never is tricky. And let's say that this is going to take x, all right? X is going to be of type string, or it can also be number. In this case, I'm using a union type. If you remember, we already saw union types. And let's handle these cases, all right? In the case that type of, and if you didn't know, you can also check the type of a variable by using this keyword type of. and then passing the variable that we want to check. And we can also check if this is one of these types that TypeScript handles by default, all right? So we can say if this is a string, then we want to do something, right? We can say console log, do something, and then let's handle the other value. But at this point, let's make a hover here. You can see that this is going to return void at this point. All right, so let's say else if type of, in this case, we're going to say if the type is equal to number, then we want to handle this as well. So I'm just going to copy this console log by saying do something. Now, in this case, if we hover, this is going to still void because this is not returning anything at this point, right? If we don't hit any of these if statements, we are not returning anything. And this is why we expect void. And if we go here, remember that if we weren't to return anything, we are going to return just void, like in this case. That's why we are returning void at this point. But let's say that we have another else statement here. And if I open curly braces and just put the X here, if I hover over this X at this point, you are going to see that X has a never type because we already handled the case in where X was a string and a number. But if we try to keep going, if we don't enter in these two cases that we are defining in this union type, this X is going to have by default never. But if I hover again over my never is tricky, you can see that now this is undefined. So at this point, we know that if we hit this line, this function is not going to return anything. Remember that never means that the function is going to throw an exception or terminate the execution of the program. Next, guys, we have function global type. And I just created this function called function global type. And let's say that we are going to receive a function. So I'm going to say func, and we can use this function global type to define this parameter function. And if I do hover over this interface that we have here, this is going to create a new function. This means that we can apply properties like bind, call, apply to this function. So let's say that I can say here func.apply, then we can say call, for example, and these properties that come with JavaScript. But let's just return for now this func and call this with some parameters, let's say 1 and 2. And if I do hover here, you can say that this is going to be of type any, which is not very good. We, most of the time we are trying to avoid any. And at this point, TypeScript is not telling me anything. So this is going to work, but we know here that we have a return value of any. So in conclusion, this is an untyped function, and it's best to avoid this global type because it's not safe to return any value, right? So in general, it's best to just say that this is going to return void in this case so that TypeScript can let us know that this is an error at this point because we are not expecting arguments. Okay, but let's just return this to be function to leave it as an example. Now, moving on to the next example, we have REST parameters. And when we are using TypeScript, we can define things like, for example, let's say that we are going to get a parameter number, but then we can expect to have, a lot of parameters here. For example, another B, C, A, and we can have as many parameters as we want. So we can use the spread syntax. So you maybe have seen this when using React. If you have used React, we can spread syntax these parameters, which means that this is going to be all the extra values that the user of this function is going to provide after this n, all right? And this is going to be, in this case, of type number. Now, because we are dealing with a lot of values, this is going to be an array of numbers in this case, but it could be whatever other value. And now, for example, in this case, what we are effectively doing is that if someone comes and says const a equals to rest parameters, and now notice, guys, that this is taking a number and then it's taking an array of numbers. So what I can do here is just say 10 as my first number. And because we are using this 3.spread syntax, it means that this array can be empty, right? But in this case, I can also add 1, 2, 3, 4, and continue. And what we are doing here is just grabbing these extra values and put it inside this array of type number. So effectively, we can say return, and I can say m.map because M it's an array, remember? So we can map over these values. And for each value, I'm gonna say X. For X value, I can maybe multiply or add the N value, which is the first number. So in this case, what the function is going to do, it's grab the first N number, which is 10, and then add the next following numbers that we have in this array, which would be at the end of the day, 11, 12, and so on. Let's see this in action. I'm gonna say console log A. Let's compile this using TypeScript. So let's say hello TS, and then run using node hello JS. And as you can see here, we have the result. So 11, 12, 13, 14, and 15. Now, another thing to notice here, guys, is that if we don't provide this type here, by default, TypeScript is going to take this argument as an array of any, which at this point, it's going to work just fine. If we try to compile this again, and then run this again, everything is going to work the exact same way. But in this case, we don't know what kind of value we are getting in this array. And in this case, we could have maybe, I don't know, a string, and everything is going to work just fine. But of course, we are trying to avoid that by providing the type, in this case, an array of numbers. By putting the 3 dot as well, we are saying that this is an array. So if I just say number, this is going to give me an error. And this is how we use REST parameters on TypeScript. And we're going to see more about this on React as well. Next, we also have the possibility of the structure parameters in a function. And I have created this parameter destructuring function, and we can basically receive an object here. And we're going to see this a lot when we are working on React, and we can pass properties here. For example, let's say that we have A, B, and C, okay? And now we can, just say console log A plus B plus C, for example. And if I hit save, if I do hover here, you can see that TypeScript, it's inferring these values by putting any, but we can type this here in line by destructuring this object. So I'm going to destruct these properties. I'm going to start with A, and I'm going to say that this is a number. Then we move to the next one, B, it's a number as well. And C, it's going to be a number as well. Now, if I do hover here, we can see that TypeScript knows that this is a number. And of course, we could also add the return value after this parenthesis here. We are going to return a number. And in this case, instead of putting this on the console, maybe we can return the sum of these numbers. Now, if I put my mouse on top of this function, we can see that this is a very strongly typed function. Now, most of the time we want to abstract this from here because it's a lot of stuff in this function. And what we want to do is generate a type alias. So let's call it parameters type. And this is going to be equal to this. And then what we can do is just put parameters type here and hit save. And this is the exact same thing. But in this case, I think this looks cleaner. This is the type, and we know that these are numbers, and we can add them. Now, another cool thing that we could do here is just say that these are going to be values, and this is just perfectly fine. But in this case, we are not destructuring anything, and we can destruct these values inside this function from these values here. And we could have IntelliSense here because we already know the type of these values. So we can grab these values and then do whatever we want with these values here. In this case, we are just adding them, and this would be the exact same thing. But I think it's cleaner, and we don't need to have this extra line of code if we can destructure this on here. And this is how we can use parameter destructuring. Now let's move on to the next one. This is going to be pretty fun. It's going to be function overloading. And we use function overloading when we want functions that can be called with different parameters and types. Let's say that we have a function called combine, and this function is going to take two parameters, A and B. And let's say that we want to have a number here, and we want to have a number here, and also this is going to return a number. Inside of this function, we can do something with these values and then return a number. But what happens if in the future we want to combine these two values as well, but also we want to have support for strings? Well, there's a very powerful thing that we can do called overloading. And what I can do is just copy this here and put it here. and I'm going to overload this function, right? So I'm saying that this combine function is going to take a env of type number, and it's going to return a number, but I want to overload this function again. And in this time, I want to have a string and a string here, and also return a string. Now what we can do here, instead of having this number, we can say that this is going to be of type any, okay? And if I do any, if I hit save now, and if I do hover here, you can see that this function has one overload. So it's grabbing the first one, which is number, and the next overload is going to be strings. So now inside this function, what we can do is check, for example, if type of A is equal to number. Of course, we need to handle these cases, and type of B it's equal to number as well, then we can return A plus B. And down here, we can have another validation in the case that they are strings, because at this point, we know that we can have number or string, so we can validate, and in this case, we can concatenate these two values. So let's use this function here. I'm going to say result equal to combine, and in this case, I'm going to pass two numbers. Let's say 6 and 4. So this is going to return 10. Then we can also use this. I'm going to say result 2 equal to combine. And in this case, let's pass two strings. Hello world. And this should return. Now let's put this on the console. I'm going to say console log result. Well, I can say result and finally result 2. So this is going to put these two results on the console. Let's compile this and then run this using Node. And as you can see, we have the result, which is 10, and the result 2, which is hello world, which is working just fine, right? And here I don't have a space, so this is working. The thing that I want to mention, guys, is that we know that this combine function handles numbers or strings. And in this case, if I try to provide a number and a string, at this point, we are going to have this error that says no overload matches this code. And this is a huge error, really confusing for beginners. And the reason for why we are getting this error is because this function does not handle this string, right? And you can see it here. Following error, argument of type string is not assignable to a parameter number. Overload to string gave this following error. So we are getting an error for each overload. In this case, type number is not assignable to a type string. So this is basically what happens when we are getting these overload errors, which means that in this case, we need to provide a number, let's say 4, and everything is going to work just fine. Now, just as a side note, guys, another way to overload this function, instead of having these two here, we could have done here a union type. So let's say number and string, and let's copy and paste this here, and also for the return type. And in this case, you can see that the function likes ending return statement. But in this case, what we can do here is that if we pass these if statements, it means that we need to throw an error, right? So I can say throw new error. In this case, it valid types, and now TypeScript is not going to complain. And this syntax, it's a little bit heavier. So you can see here, we have these union types, and it's a little large. And now we don't need this anymore. We can just comment this. But if I go back here and try to use a string, we are not going to get the error here, but we are going to hit this line of code here that is going to say that invalid types. Okay, this is another way to use overloads. If I do false, for example, in this case, we are going to have this error here because this type is not being handled by any of these union types. So let's just put this back the way we had it before. And this is how we can use function overloading with TypeScript, guys. So I'm going to finish this lesson with this. I hope you like it. I hope you learned something new. I encourage you to follow along with me and play around with these examples. And otherwise, I'll see you in the next one. Thanks for watching. Bye. Hello everyone and welcome back to Code with Beto. In this lesson, we are going to learn about React components and JSX and TSX. So let's get started. Alrighty guys, so here we are on the workspace that we created for the first time when we create our first React application using Vite. As you can see, I already have the server running on this port. And this is how the standard Vite React application looks like. We already saw this on previous lessons. And as you can see here, if I open the terminal a little bit, you can see that this is running on this port. And let's start thinking about components and JSX and TSX in React. So most of the time, guys, as you can see here on the left side, we already saw a little bit of the structure of this project. Most of the time, you're going to see that we have this source folder, and inside this source folder, because this is just a new application that we created, we have this app CSS, app TSX, because this project doesn't have any other configurations like TypeScript or any components yet. So when we were talking about React and the advantages of using React, we saw that React allows us to use components to decouple and abstract logic in small pieces so that we can reutilize those components and separate concerns, and that leads to better maintainability of this project, easy to scale. So most of the times inside the source folder, you're going to see that we have a components folder, just like that. And if you don't have one, you can just create one. This is the place where we are going to be putting our components that we are going to be using on this application. Remember, guys, we want to have as much components as we can, but without, how can I say this, without creating components that doesn't make any sense. So we want to abstract logic that we are going to be reutilizing, right? And the first component that comes to mind is going to be a button. So we use buttons when we have forms, when we want to increase a counter like the one that we have here. This is a button. And if I press this button, you can see that the count is increasing. So we don't have any component for this button yet. And if we open this app.tsx file, you can see that we have this logic here and everything is put, everything is here. You can see that here's the button. Let me close the sidebar. This button is basically, created here. It's not abstracted. And if we want to create another button, what we would need to do is going to be just copy this and maybe paste it down here. But at this point, we are making a mistake because rewriting this piece of code twice, and we could abstract that in a component. So that's why we need to use components, right? Now, another thing that I want to mention, when we are using React, basically we are writing TSX or JSX because we're using this project with TypeScript. You can see that here it says app.tsx. So the extension TSX basically is saying that this file is going to be a React file, right? We are going to have JavaScript and HTML combined in this file. This is why we have this TSX. And if we were using JavaScript, we would have something like JSX, and this is how it looks. But because we are using TypeScript, we have TSX. Alrighty. When we are dealing with TSX and JSX, it means that we are writing JavaScript. So let's go ahead and try to abstract this button that we have here. So inside my components, I'm going to start by creating a new component. So let's say new file. And because this component, we want to reutilize this component a lot of times, let's just call it button.tsx. This button component is going to be reutilized maybe in the profile screen or maybe in the home screen. Now to abstract this button, what I want to do is just go to my app.tsx and then just cut this button that we have here, right? I'm going to cut this, and then you can see that we have an error here because we are not using these variables, but don't worry, we're going to abstract that as well. So what I'm going to do here, when we are creating a new JSX or TSX file, in this case, a piece of component or piece of my application in React, we need to declare a new function, or it could also be a class if you are dealing with legacy code, but in this case we're going to be creating a function. So this function is going to be my component, and I'm going to say that this function is going to be called button, and we need to return a JSX element, right? Because this is a JSX component. So let's return, and inside my return, I'm going to paste my button. All right. Now we have a bunch of errors here. The first one is that we don't have this state here. That's why we can no longer, use this function here. As well, we haven't seen this yet. We're going to learn more about hooks. So I'm going to go ahead and delete this here. And what I want to do whenever the user presses this button, it's going to be actually just show an alert on the browser. And the message is going to be, you have clicked. So clicked like that. Now, instead of using this text, I want to change this to be something more simple like press me, and let's hit save. Now, let's see what's going on here, why we have this error. So fast refresh only works when a file has exports. Basically, what this error is telling us is that this button component that we just created here that says press me is not being exported, which means that no one is using this button. So let's go ahead and export. So I'm going to say export, and now we are able, because we are exporting this button, we are able to use this function. We can just go back here to the app.tsx and just delete this use state for now. We're going to learn more about hooks in the future lessons, but for now, let's just keep things simple. I want to start by going down here. If you remember, the button was inside this div. So now instead of having the tag button, I'm going to be using my component. And if I just start writing button, as you can see here, IntelliSense is going to show the button that we created, and it's inside the components folder. So if we click here and close this tag like that, we're going to be able to use this button. So if I hit save, you can see that now in my application, we can see this press me button. This button is utilizing, doesn't have any styles, but it's being styled here, as you can see, and it has a hover state and all that, because by default, when we created this application, we are importing app.css. And if we go to the app.csx file here, you can see that we are selecting this button, where it is. Let me see. Actually, it's going to be the index.css, and the index.css has this button class that is being applied to this button. Now, I don't want to dive into styles at the moment, but I just wanted to mention that this button is being styled by this class. And if I comment this and save, you can see that the button is going to look very different. We have also the hover state here, and we're going to learn more about styles in the future as well. So for now, we know that this style is being applied to this button. Now we have another warning here. The reason for that is because we are using or importing use state from React, and we are not utilizing it. So let's go ahead and remove it and hit save. And everything is working fine. And if I press this button, you can see that we have this alert here that says you have clicked. So let's say okay. So now what we've done here. So what we have done here is decouple or created a component so that we can reutilize this button. Okay, now if I want to have another button here, I'm going to duplicate this a couple times, and you can see that we have 4 buttons. Now these buttons are being styled from left to right because they are inside this div, right? But if we, let's say, just cut one and put it outside this div, you can see that this is how it's going to look. Now this is very powerful, guys, because we have created this component. We are able to reutilize this button. And this is how you can start building your application, by abstracting little pieces of code that we are going to be using a lot of times. Now, a button is a pretty common one, but you can abstract as low as you want. What I mean is that you maybe want to abstract a title, for example, an H1. But what are the advantages of abstracting this button? So let's say that we had another screen for the profile screen, and we want to, let's just have a div here and have a maybe a p tag that says profile, okay, and save. And inside this, we want to reutilize the button. And in this case, let's say that the button is going to be to do something else, but we want to have, the same style for this button in every single application, or the same, the same context, the same functionalities. Now, because we're abstracting this button, let's say that we want to change something on this button. And if we were to duplicate the code that we had before, we would need to go inside each single button here, like we had it here, and change whatever we need to change on this button. But because we have this component abstracted, when we want to change, or when we need to change this button, we can simply go to this component and change it. So let's say that now instead of say press me, we can say just press. and if I hit save, every single instance, as you can see here, of this button is going to change to be press. So this is a huge advantage of decoupling the components into little pieces that we can reutilize, so that when we need to make some changes, and we of course are going to need to make some changes in the future, every single application needs to make changes, it's going to be easier for us to do that. Okay, this is the advantage of using components. Now, keep in mind, guys, that when you are creating a component, you need to use the TSX or JSX if you are using JavaScript, and then this is the extension. And basically, JSX, I want to take a moment to tell you a little bit about what is JSX and TSX. Basically, it's the combination between HTML, as you can see here, this tag, it's HTML at the end of the day, and JavaScript. And this function is JavaScript. As you can see, this return is JavaScript. So this is the combination, and we weren't be able to combine this in just vanilla JavaScript. This is why React is super powerful, because it allows us to have JavaScript inside these components. Now let's say that we have, some variable here. I'm gonna say let my variable, and this could be equal to, let's for now just say a number that is 1,000. So let's say that we want to show this variable here. We can simply open curly braces and say my variable, hit save, and you can see that this is going to update every single instance of this component. Now I'm going to change this to be const so that I don't have that warning. And this is how we can use JavaScript inside this component and then render it. Now the cool thing about this is that we can have some validations and start by adding more functionality and create these and make this component a little bit more complex. For example, let's say that we want to have a title if I don't know, if this number, let's say that this is available money. Okay, so let's say that this is the available money of the user, and then inside this component we want to have, for example, a text that says you have more than 1,000 or you have less than 1,000. So depending on the available money, we can have validations inside this button. So I'm going to say inside curly braces. So every time that we are dealing with variables inside a component, we need to use curly braces, and then let's say available money. And here we can have validations. For example, if this is greater than 1,000, it means that, so I'm going to be using a statement or ternary statement. So if this is true, what I want to do is going to be just have a text that says more than 1,000. And otherwise, what I want to do is have another text that says less or equal, right? Equal to 8,000. So in this case, we are seeing that when I save, this text is going to change to be less or equal to 8,000. Less or equal than 1,000, okay? Now, let's go ahead and change this variable to be 1,001. Now, if I save this, you can see that everything changes and React re-renders because this variable changed, and I saved this change and everything is going to re-render. But in this case, we are showing more than 1,000 because this validation, it's been true in this case. So that's why we are setting this variable here. So this is the power of combining JavaScript with HTML, and that allows us to have these kind of validations that you're going to be using a lot when we're using React. Now, another cool thing about JSX is that you can also save components inside variables. So let's say that we want to have this text inside a p tag or an h1 tag, for example, or h2. So what we can do is abstract this into a component. So for example, just to show this, it's going to be I'm going to create a constant called my components like this, and this is going to be equal to a p tag, or let's just change this to be an h3 for now. Okay, and this is going to be my component. Now this warning, it's because I'm not using this variable. So inside this button, I want to use my component. Now, because this is a component, remember that we need to use uppercase. So I'm going to say my comp and close this tag. Okay. Now, if I hit save, I'm going to get an error. Let's see what's going on here. So a JSX element type, my comp, does not have any construct or call signature. What was the error here? Well, this variable, is just being assigned to this h3. But remember that when we are using components, we need to have them into a function. So let's create a function here. This is an arrow function, and this arrow function is returning this h3. Now, if I hit save, you can see that we have this h3 that says my component on each single instance of this button. Cool, right? So this is another way of creating components. In this case, we are using an arrow function, and because this is in one line, this is a implicit return. But if you want to have more functionality, you can have this inside curly braces, and then we would need to have a return statement. So this is how it would look, and everything is going to work the exact same way. Now this is going to start looking in a different, well, basically in the same way of this button. We are creating another component inside this component. Okay, so this is pretty cool. Now, if you plan to reutilize this component, maybe it would be a good idea to abstract it into another component inside this components folder. Okay, but I just wanted to mention that you can have something like this. Now, let's say that we want to change this myComp for something like button title. Okay, this button title is going to be changing depending on the available money. So let's put this available money variable inside this this component, and then change this to be button title. And instead of having this available money here, I'm just going to delete it and put it inside this component. I want to have a text, so we can say const text equal to, and the text is going to be depending on this validation that we have here. So we can simply cut this and paste it here, and then delete these curly braces. And instead of returning this my component, I can open curly braces and return the text. And if I hit save, you can see that this is working just fine. But in this case, we are just returning this component that is handling its own logic, right? So we don't need to worry about the content of this button, because this component is going to be dealing with that. And this component button title, it's basically validating. And if we change this to be 1000, for example, you can see that everything is going to change. So what we are doing basically is just utilizing JavaScript and TypeScript to render stuff to the user. Okay, in this case, it's going to be this simple text. Now, of course, we are using TypeScript, right? And when we are using TypeScript, in this case, we are not, typing anything. Everything is going to be inferred by TypeScript. And if I hover this, you can see that this is going to be of type 1000, which is not very descriptive. In this case, we are assigning this to the value that we are specifying here. But if we want something more generic, we can type this by saying that this is going to be of type number and this is going to be of type string. Now, when we have components as well, we need to type them. In this case, if I hover over this button, you can see that TypeScript is inferring that this is returning a JSX element, which at the end of the day is a component, but I want to explicitly type this here. Now we are using TSX in this point. We are using TSX and we are typing everything. Now if I hover these, you can see that this is a JSX element as well. This is the returning type of this arrow function. So what we can do here is just type this as well. Okay, this is the signature of this component. Cool. So everything is working just fine at this point. I just wanted to mention that we can also have this export function button as arrow function if you prefer. So if you prefer to do that, we can say, for example, const and then button, and this is going to be equal to an arrow function. Okay, so I'm gonna have my arrow function like this, and then I'm going to delete this here. And of course, we need to export this as well. Now, in this case, we're using a arrow function, as you can see, and we have the same signature. Now, when it comes to using normal functions versus arrow functions, I would say that it comes to preference from the developer or whatever your boss is telling you to use, but just try to be constant. If you are going to be using functions or arrow functions, try to use them in every single component. If you're going to be using just normal functions, try to use normal functions on every single component. Now, if we come back here, you can see that nothing has changed and we are importing button from components. Now, another thing that you may have seen, we are importing this inside curly braces because we are importing this as a const, but we could also export this default, right? So I'm going to say down here, export default, and then button. So what this is doing is exporting this button from this file by default. And when you have just one component inside this button, which is the ideal case, you want to export this default. So if I hit save now, we need to change this import because this is not a constant anymore. What we can do is just delete these curly braces and use this button like that. So the advantages of exporting a JSX element like this is that you can rename it because this export is going to always return this button and you don't need to name it button. What you can do is just maybe change this for my button and then copy this and replace every single instance and delete this, and everything is going to work the exact same way. But in this case, it might be useful if you want to change this button name. Okay guys, so this is basically how we can create components. Now as an exercise, it would be nice if you can start creating other components, maybe for the header, maybe for a sidebar, and yeah, so I hope you like this lesson. I hope you learned something new. And in the next one, we're going to learn more about components and how we can deal with properties. Okay, so I hope you like this lesson and I'll see you in the next one. Thanks for watching. Bye. Hello everyone and welcome back to Code with Beto. In this lesson, we are going to learn more about props and state in TypeScript and React. So let's get started. Okay guys, so here we are in the same example that we've been working, and in the previous lesson we created this component button, and this component is working. If I press this click me button, you can see that this alert is shown. So this is working fine, but whenever we are trying to reutilize this button, if I go to my app.tsx, and I'm going to delete some of this stuff here that we are not using, this property, and I think I need that div. And then maybe we can delete these images and this div. So here we are, this is the React application. We have this click me, everything is working. But let's say that we are trying to, having more screens, having more sections in our application. And let's see what's going on with this card so that we can see where is this card and how we can create other card, right? So let's go to the app.css and search for card. And you can see that here we have this card, and I can say border 1 pixel solid red and hit save. Okay, so this is a card, right? Now let's create another card, and maybe we can change this to be a cyan so that looks cooler. Let's go back to the app.ts and let's create another div container. Okay, so we have two cards at this point, but let's say that the first one is going to be like a profile. So we have this profile and we have this button, but in this case we want this button to say, I don't know, sign out, for example, right? And here I want to have some space. So what we can do here is put this in curly braces and then add a space like this. So we have this profile, but we are reutilizing this button. But in this case, this button doesn't allow us to change anything about how it looks, about the functionality that this button has. This is where properties come handy in React. So let's say that we want to do something different with this button, or have a different title every time that we reutilize this button. So we can use properties in React to handle those cases. The first example and more simple example that we can see here is, for example, declaring props, right? So in this component button, I'm saying that I'm going to be getting some props. Now, instantly, TypeScript is yelling at me because I haven't defined the type of these props. So for now, I'm just going to say any, and now I can use these props. So this button has this onClick event. And for now, I'm just going to delete this handler completely so that we can see better. And in the props, I'm going to include a title. So let's change this. And I'm going to say props.title. Now I'm getting this warning because specify a different type. Now I'm getting this error because I'm trying to access a property of these props, right? So TypeScript is inferring that this is an object. So it's giving me this quick fix use unknown. In this case, now I'm going to have this error here. So let's put this back and let's just leave this like that for now. Now, if you pay attention on the right side, this button now, it looks super different. It doesn't have anything. So let's go back to the app.ts and provide these properties. So the way we pass properties to this component, it's going to be just by passing the name of the property. In this case, it's going to be title, and the title is going to be, in this case, sign out. And if I hit save, you can see that this is working despite the errors that we're getting from TypeScript. And of course, I'm not using this anymore, so that's why I'm getting those errors. But now, because I'm passing this property, you can see that this is working, okay? So despite this warning, this is accessing this title inside this object. Now, to have a better understanding, we can inspect this on the console. And I'm going to create my console a little bigger here. And let's put these properties on the console so that we can see them. So I'm going to say console log props. And if I hit save, you can see that it's getting rendered twice, because if I go to my, I believe it's going to be main TSX, we are using a strict mode. And strict mode re-renders everything twice. So for the sake of the simplicity of this example, I'm just going to delete this strict mode here and delete this import, so that we only have one of these, so we don't get confused. Okay, so I'm going to close this main. Now here we can see the properties that we are getting. But now, because we're using any, we don't know what we're gonna be getting here in this object. And at the end of the day, if you pay attention, this is an object. Okay, so if I go back and delete this and try to write something like title or subtitle, I'm not getting any IntelliSense, any autocomplete, nothing. So let's clear the terminal and let's actually use TypeScript in our advantage. Okay, we saw that properties are an object, and if you remember, if we are using objects, we can destructure them. So I'm destructuring these properties and grabbing the property title. Now, this is going to give me an error, so I'm going to say that this any as well. And now, because I don't have these props anymore, I can say just title and say title here. Now everything is going to be, in this case, undefined because we are not passing anything here. But if I come back here, the way we can type this object, and we saw this on the TypeScript section, it's going to be by saying the property as well, and this is going to be a string. This is the correct way to type this property. Now, because I'm typing this, TypeScript knows that this bottom component is missing a property. And if I hover here, you can see that property title is missing. So what we can do is just say title. And if I just press T, you can see that IntelliSense of VS Code, it's telling me, oh, you are trying to write title, because I know that the component gets a title. So if I simply hit enter, automatically, I didn't have to write this because I typed and I told TypeScript that this bottom component is going to get a title of type string. That's why we have this string here. And now I can say here, sign out safely. And we can do the same here. But in this case, I want to reutilize this button, but the title of this button, it's going to be something like register. And if I hit save, we have successfully put on the console the variables that we are getting on each one of these instances of this component. So every single component is getting its own state, its own variable, and they can also have their own functionality, like its own functions and stuff like that. So we are effectively using the same bottom component, but we can improve this a little better. But we can improve this a little more. In this case, we are destructuring this type, but what we can do, it's actually use a type. If you remember, we learned how to create types on the TypeScript section. So I'm going to say that the type of this component is going to be bottom props. And this is going to be equal to a new type, right? So I can just start writing the properties that we are expecting here. Now, because I have this type, I can simply say that the properties that we are going to get are going to be of type bottom props. And we know that bottom props have this title. So this syntax, it's cleaner. We prefer this syntax. And now, because we are typing this, if I try to do something like, let's say that I didn't write this title correctly, TypeScript is going to let me know. It's going to tell me that this variable declared, but this value, it's never used. And also this property does not exist on the type button props, so that I can realize that I'm missing this E and I can save a lot of time. So this is the magic of properties, guys. But this is a very, very basic example. So in this case, I'm going to close my console here. We have two parts of this application, right? So the first one is the profile, and then let's say that this one is going to be the home screen. So I'm going to copy this and change this to be home. Okay, so we have profile and home, and maybe I can make this bigger so that we can see better. So we want to have a function whenever we press these buttons, right? So maybe just a simple onClick event. But if I write onClick here, I don't get any IntelliSense. The reason for that is because we are not expecting anything else on this type. So what we can do here is actually declare a function, and the function that we're going to be using is going to be onClick. So by default, HTML elements have these kind of events, and we're going to learn more about these events in the next lessons. But for now, let's just hard code this onClick on these properties. And if you remember, we learned how to type functions on types and interfaces. So we can simply say that this is going to be a void function. Okay, this is how we type a function. Now we are saying that it's just a function that does not take anything or return. It doesn't return anything, so that's why we said void, and we are not getting parameters. Okay, so we are not getting parameters, we are not returning anything, just a simple empty function. And now because I have put that on my type, I can simply destructure this here, and I have this onClick. IntelliSense is helping me. Now if I come back to my onClick event that I have from HTML, I can have a function here, right? So that we can pass the onClick function that we are getting on the properties. So that when we press this button is going to call this function that we are passing as property. Now, if I hit save, you can see that now we're getting an error because we are missing this onClick. If we don't want to provide this onClick event, we can make this variable optional, like we saw on the TypeScript section as well. Now the warning disappeared, and whenever we press this, nothing happens. Okay, cool. So now I want to specify an onClick event specifically on the sign out. Okay, so on the sign out, we can have this function here, or we can simply call another function. In this case, I'm going to put an alert that says sign out and hit save. Now let's try this out. I'm going to press the sign out, and you can see the alert here. And if I press register, nothing is going to happen because we haven't provided a function to this component. So at this point, we are realizing a component with different functionalities. This is very powerful, and you are going to be using this a lot throughout this course and throughout your career using React. Cool. So now let's see something a little more complicated. Something that I think I forgot to mention when I talk a little bit about component is that each component is going to have and it's going to deal with their own state. I'm going to be using just a simple use state hook. I know that we haven't seen hooks yet. This is the example that comes with this application when we create it for the first time. It's just a simple use state example. So I'm going to have a counter just so that we can see that this component is going to be managing their own state. Counter and set counter. We're going to be using the use state hook from React. So we are importing use state, and I'm going to have this to be a number. So I'm going to be specifying here on this generic that this is going to be of type number. And then I'm going to initialize this to be 0. Now, whenever we are clicking this button, I want to increase the counter and put the counter here next to the title. So I'm going to say title, and then I can say number of clicks equal to, and then we can open other curly braces and say counter. And if I hit save, you can see that each button is going to have now this number of clicks property. Cool, so this is working fine. And I can have a tag BR, I think, so that this is going to be in the next line. Cool, so we have this working fine. Now I want to, do this logic that we are passing on these buttons. And on top of that, I want to increase my counter on each component. So what we can do is actually create an inner function or a function that is inside this component that is going to be in charge of calling the function that we are getting as property and also increasing this counter. So let's say function handle handle click. Okay, this is just a normal function that is not going to get anything as parameters. It's just a handle click. The first thing that I want to do is handle the onClick part. So I'm going to say onClick. And then what I want to do is going to be set counter. And the counter is going to be equal to the counter plus 1. I want to be increasing this. Okay, so I have this error now. Cannot invoke an object which is possibly undefined. Okay, so if you remember, we said that this was going to be optional. That's why we're getting this possibly undefined. So let's make it obligatory to provide this property. Now, instead of calling onClick here, I want to call my handle click. Perfect. So if I hit save and I go back here and add this onClick to my other button, so I can copy this. Instead of having this sign out, I can have something like register. Let's go back to the button TSX. We are handling the logic on this function, and let's click. And then we are re-rendering this component because we are updating the counter. So we are replacing the state with the state plus 1. And if you pay attention, this button is the only one that is updating, or the number of clicks it's increasing. The reason for that is because, like I mentioned before, when we are dealing with state inside a component, this is going to be created multiple times depending on the instances of this component. In this case, we have 2 instances, and that's why each one of these instances is going to be handling their own state and their own logic. Okay, so keep that in mind, guys. And yeah, so now let's see another example. Now that we know that each component is going to be handling their own logic, they can receive properties, but now I want to dive a little bit deeper on what kind of properties we can get on components, right? So in this case, I'm just using the onClick and then the title. Maybe we can have a disabled that is a Boolean, and let's make this optional so we don't have to provide them. But then we can have more complex functionality here depending on this property, right? So if we are disabled, maybe we can render other things here. For example, maybe we can have a validation like we did before. I'm going to create a title that is going to be equal to this. So I'm going to cut and paste. Now I'm getting an error here because this title, it's the same name that we have up here. So let's say string. This is going to give me an error because I have this BR. But if I just try to have this in a way that it's going to work, like concatenating this as strings, and then delete these curly braces, okay? And then concatenate this. So we have this string, right? We are grabbing the title, we're grabbing the counter, and then we have this string here. But we can have a validation. So if this is disabled, and let me destructure this here, disabled, we can say disabled, we are going to have something like disabled, and otherwise the title. And now I can use this variable string inside my button. And remember that we need to put this in curly braces when we are dealing with variables. Disable is optional. Of course, it's going to be false at the beginning. That's why we are passing to this case. But if I go and say that the first one is going to be disabled and hit save, this button now is disabled. It has the same functionality, but we can also do more complicated things like say disabled equal to disabled, which is the variable that we are getting. And if we are disabling this button, you can see that now we cannot click this button anymore, but this is going to work just fine. Same component, same things, same functionality, but because we are starting dealing with these more complex properties that we are passing to this component, this seems like a complete different component, right? So this button is working, has a title, and this one, despite it's the same button, we have disabled, we don't have any titles. So this is very powerful. This is the magic of React, I would say, having the possibility of abstract our code into small pieces called components that can receive properties and manage their own state. This is very powerful, guys. And now, just before I finish this, I want to mention that we can also have more complex properties, and we're going to learn more about those in future lessons. But for example, let's say that we have some onChange function, and in this case, this function is going to get something like an ID of type number. Okay, this is how we can type this, and we learned this on previous lessons. Now we can have more complex things, of course, I'm going to make this optional so that we don't have any errors. Let's say that we are going to get an array of objects. I'm going to say object array, and this is going to be optional. And this is going to look something like ID of type string, and then this object can also have a title of type string. In this case, we are saying that we are getting an object that looks like this, and then instead of having just one, we can say that this is going to be an array. In this case, I would encourage you guys to create another type and abstract this because this is getting complex to read. So in this case, what we can do is create a type, or if you prefer, you can create an interface as well. And this interface is going to be, I don't know, something like object array, and then we can have the same properties that we have here. So I can just cut and paste here, and then I can simply say that instead of having an object here, I'm going to have this type. Now I'm specifying that this is going to be an array, and if I hit save, it's going to work just fine. Or we can say that this is just one item or an array. Okay, so these are more complex data structures that we are declaring, and we are saying that we might get these properties, right? Now if we come back here, we can, you know, pass this object property, object array, and if I hover here, you can see that this is an array of object array, or undefined because we said that this was optional. So I'm going to pass an empty array, and this is going to be completely valid. But if I open a curly braces, because I declared that each one of these elements was going to have an ID and title, I have this intelligence telling me what to do, right? So ID is type string, and then we also have title of type string. And if I hit save, this is going to work just fine. So this is the power of properties and how we can handle this kind of functions. Before we finish this lesson, I want to also explain or just touch a little bit on this property that you are going to see a lot. In this case, let's say that we have a set state. Okay, let's say that we are going to receive a setter like the one that we have here. And if I hover, if you remember, we also saw a little bit about this on previous lessons. These are types that React has declared to use this setter action or set state action. Let's say that we're going to have a function on these properties. So what we can simply do is actually just copy this and paste it here. And of course, delete these dots. Okay. And we are grabbing this from React, dispatch, and then we are using these generics to specify what kind of action. In this case, it's going to be set state action, and the setter is going to be a number. But of course, we could set this to be a string, and finally make this an optional. And then we can just grab these properties from the type and destructure them on this bottom, like set state, and finally use this set state here, for example, set state. And now because we told TypeScript that this was going to be a string, if I hover, I should be able to see that this is going to receive a string. And if I try to put a number, for example, I'm going to get an error. But if I put a string, this is going to work just fine. Now I have this error because this is possibly null. So what we can do is maybe just validate if set state it's different than null, or just leave it like that. Then we can set the state. So we can go on and on adding properties and adding more complex functionality to this component. But this is basically how you can handle properties with TypeScript in a React component, guys. So don't worry if this is a little bit overwhelming. Just try to practice, I would say. Try to practice, try to create other components. If this is the first time that you are dealing with this, especially in TypeScript, don't worry. I'm going to link you down here some resources for the more common types that you can use, cheat sheet that you can use to refer to the types that you can use with TypeScript and React. I would say that these are the most complex ones. But yeah, I'm going to leave down here some resources that you can use, and I would encourage you to practice, maybe create other components like a sidebar, like a header, and stuff like that. And that's it for this lesson, guys. I hope you like it. I hope you learned something new, and I'll see you in the next one. Thanks for watching. Bye. And that's it. I hope you liked this sneak peek of the course, and I hope I got you inspired of keep learning and improving your skills. To learn more, go to codewithbeto.dev and check out the full course. I hope you liked this video. Don't forget to like and subscribe. If you have any questions, please let me know in the comments. Other than that, I'll see you in the next video.